Road traffic is dangerous, we know that, but the greatest danger it poses is tiny and completely underestimated. Correct, we are talking about traffic-related emissions. In other words, tiny particles released through the exhaust and wear of parts enter the air we breathe. This happens, for example, when braking, while rolling and burning fuel. In semi-open enclosed environments like underground stations and tunnels, the effect is particularly bad. Retrofits are transition technologies until the full electrification of Europe's transport fleet. Even beyond, brake retrofits play an important role in the electrified fleet. AeroSolfd is an EU co-funded project that aims to deliver affordable, adaptable, and environmentally friendly retrofit solutions to reduce traffic-related air pollution. Eliminating the harmful effects of ultrafine particle emissions from engine combustion on health and the environment is urgently needed in the transition towards cleaner mobility. In AeroSolfd project, we develop and demonstrate a cost-efficient tailpipe particle filter for the European gasoline fleet segment, which currently drives without any exhaust filter technology. This retrofit solution can replace the underfloor silencer, but is less noisy than the original vehicle and eliminates the number of solid ultrafine particles emitted. Brake dust is also considered particularly toxic. Not only vehicles but also buses and trains emit large amounts of emissions from brakes, tires, and rail wheel contact. Therefore, we will modify an existing and proven passive brake dust particle filter concept for passenger vehicles for bus and commercial vehicle brake applications. This solution, which is specially designed for long-lived public road transport assets like buses, will reduce brake emissions and capture brake dust at the source. Fine particles in semi-closed spaces like metro stations and bus stops pose a threat to human health. To tackle these challenges, we will provide an effective stationary air purifier that captures particulate matter from the environment and safely trap it in the filter, reducing exposure for public transit passengers and workers. In AeroSolved, our aim is to offer sustainable solutions with substantial social benefits achieved through an overall sustainability assessment focusing on the environment, health, and social dimensions. Get to know more and visit our website.
Get to know more? You don't need to visit the website. Today you can join online and you are here on site. Welcome to this AeroSolfd final event. And before we join, some more, let's go that way. Welcome to this event. There's a quick agenda. I will go through that later on. Just to let you know, we have prepared a lunch break for those here on site, and we have a networking after the online event that will happen later. Before we start, some useful information for you. Here, the agenda, you can look at the QR code, and if you don't have a Wi-Fi yet in the room, there are some QR codes on the side that you can scan, and it immediately connects you. The emergency exit is, you can see, follow the signs, and for the restrooms, they are on that side over here. We will have at noon a lunch break that helps all the online participants, and it somehow fits to the time here in Spain. And we will have a short break in the afternoon, networking on site. Something that you find here in the conference room is you see a seed paper, a growing paper that will create a plant later on if you use it right. And we have some work for you to do because it was a project where we had to work all together. So you have this one over here. It's showing the partners as well as our motto, the fast track to cleaner urban air. If you fold that one carefully, it's something not only for the air, it's something to make a lot of noise if you want to do that. So if you later want to applause, you can use that one over there. So with that, I would like to start and open the event. And we will start with that opening session. So a quick overview about the project to get you to know what we will be presenting here. My name is Martin Lehmann. I'm with Mann & Hummel, a leading filtration company separating the useful from the harmful. And my role today is the coordinator of that AeroSolfd project and moderating this event together with Ute Bock, who will introduce later on. And I'm talking here on behalf of the great AeroSolfd team, so it was a wonderful collaboration. What is AeroSolfd? When I submitted it some time ago to an American filtration conference, they said it's a typo, but it's not. It's a real acronym that's telling a story. We are looking not only for cleaner air, we are looking for cleaner aerosols. That means we are looking for particles, for gases, and want to have clean aerosols in the cities, in urban areas. And we want to do that by market-ready solutions. And we do that for tailpipe, brake systems, semi-closed environments like metro stations. And we do that by retrofit solutions, something that you could put in place to existing vehicles, to existing metro stations. And we do that by filtration devices. And if you put that together, you end up with AeroSolfd, a nice project. The three solutions: tailpipe, we are reducing the emissions by a particle filter. We are reducing emissions of brakes in urban area above buses, for example, by a brake dust particle filter. And we are reducing the exposure to pollutions at metro stations by adding a filtration device over there. The projects, it's a collaboration between 17 partners in 9 countries across Europe. We were addressing the topic in the Horizon Call 2021, development and demonstration of cost-affordable and adaptable retrofit solutions for tailpipe and brake polluting emissions. It's funded under the grant 1010-56661, and we started in May 2022. We are lucky that we got an extension because that's important for our life cycle and environmental social assessment. In session 2, you will hear more about that. So we will end in August. We have the event before the summer break here to let you all know what the results are. We got 5 million funding by the EU. We are very happy that we have a partner in Switzerland that brought in 2.2 additional funding, and the industry is contributing as its innovation action with 1 million. So, of course, this is an EU-funded project, co-funded project, but the content is the one of the project partners. So views and opinions expressed are, however, those of the authors only, and do not necessarily reflect those of the European Union or the European Climate, Infrastructure and Environment Executive Agency, CINEA. Neither the European Union nor the granting authority can be held responsible for them. And as it is with Switzerland, we need to add Swiss participants in the AeroSolfd projects are co-funded by the Swiss State Secretary for Education, Research and Innovation, CERI. With that, I would like to guide you a little bit through the agenda. You can see the logos of the partners that are the partners that contributed to this session in particular, but they are also contributing to the others session. So it's a nice collaboration, and I would like first to thank Steinbeiß, who is organizing this event for us. So you can see Marta and Pierre is somewhere around here in this room. If you have any questions, contact them. The structure we have given for today is we start with a why. Why are we interested in having cleaner air? Why we want to drive, and who is driving cleaner air in cities? Air quality matters. Intech and K-Health and Air will talk about that. Then we will go into the how do we assess that it's really making an impact. We are looking at sustainability. And after that, we tell you what we do. What are the solutions? They're ready for retrofit. And then we look into the next steps. And we are happy that this is a collaborative event here. We have EIT Urban Mobility here. We have our partner from the Vera project here as well. So looking forward to a joint approach and talking together, exchanging. There's a Slido option on the website to have your questions. So it will be a very interactive event. Let's look what we can do, and let's strive for cleaner air as a fast track with AeroSolfd. With that, I would like to welcome our project officer. I would thank our previous project officer, Salima, for the guidance and the support of the project. And I'm welcoming now our new project officer to this one, and Manuela Flachi to this project. And we are looking forward to some opening words from your side. We can see you, we can't hear you at the moment here, but it's a great picture.
Yeah, can you hear me? Can you see me? Yes?
Yes, now it's working perfect.
Yeah, okay, good. So thank you very much for the invite today, and good morning to all. Indeed, I am a new project officer as senior, and I'm replacing Salima, who is also here, by the way, listening to us today. And she, when we prepared the handover, she always told me, well, this is a very good project, very well managed, and especially she was impressed. So she was stressing out the professionalism, the consortium, and the scientific implications that you all have, you all had. So I'm confident, let's say, that you have reached the targets and the objective set. And I arrived at the end, unfortunately, but somehow just lucky enough on time, because I can still witness, let's say, what you have done, the work done, and the project results. And about that, I would like to remind and to stress very much what were the main objectives of the call, for which we expect that AeroSolvd will achieve them all. That is, of course, to reduce the negative impact of transport on air and water quality due to tailpipe and brake emissions from older vehicles, to accelerate the improvement of air and water quality. So we're not waiting for 10 years time for the vehicles to be replaced. We need solutions now that have to be affordable, retrofit technology. So we are aiming to see that, and at the same time reducing for real the emissions, and ultimately also to reduce the negative health impacts of the users and workers. So as said, we expect that AeroSolvd will achieve all of them. And I'm also very pleased to see that the sister project of AeroSolvd Vera is here, that was invited and has a slot later on in the afternoon. So looking forward to hear from them. And that said, that well, I wish you a great day, and thanks a lot again for inviting me, and let me, yes, well, that's all from my side.
Thank you very much for the kind words and for putting the expectations. We will do that and present today results according to that. We are lucky also that we had the opportunity to be in Barcelona, that it's this location where EIT Urban Mobility is located, where our partners that are interested in doing, and we had yesterday already a pre-event together with the Ideal Cluster, where other partners are working on air quality in metro stations. That was a very good exchange organized by Jose and Ruben from the K-Health in Air project. And we are happy that we are second time in this room. We had a metro workshop on this, on air quality, and Teresa was the host at that time. And Teresa, some words about CSAIC and the location.
Thank you, Martin, and thank you all for coming. I don't know what to say, just to more than welcome again. I'm very happy to live in Barcelona. I'm not from Barcelona, I'm from Madrid. That's the enemy in football, but it's okay. We don't talk about football. But I know it's always nice to see you here because the location is very nice. And the project, after all this time, these 3 years, has been progressing a lot. And I think the meeting we have here last year, it was very interesting, but today is going to be when we put everything together and we are going to see what we saw. So it's a pleasure that you choose to come to Barcelona to do that. If you have any problems or you need any help, please, Stefanos or myself, we'll be very happy to help you. Thank you.
Thank you very much. And with that, we will start looking into our first session, into the why air quality matters, what we want to do. You will get a quick intro into the project again, and then we have a keynote, two keynote. One is about citizen science, that's very interesting, and one about the EU directive that will drive air quality and put in some changes. And afterwards, we will have a panel discussion. So to start this part, we have the major contribution of our partner Intech on social science on this one. We will have later a guest from K-Health and Air from the IDEA cluster, 7 projects working on indoor air quality and health. And that will be a nice way to look into air quality. So let's start with a short overview of the project to get you all on board, to give you a little bit an idea what you can expect during the day. It will not give you all the results in a nutshell. But it gives you an idea when you should really, if you are online, be here in the sessions, join, and when you might take a coffee and when you shouldn't take a coffee. And for those in this room, you are here to hear more about AeroSolfd. And as I said, this is a fast track. It's something that you can implement easily for cleaner, healthier aerosols. And we do that by market-ready solutions. So we will have something that's approved, that's ready to hit the market and to be on the shelf. And we do that for tailpipe, brake systems, semi-closed environment, and we do that by Retrofit Solutions. We have some pieces here, some you find on our website with some pictures. If you want to know more about the products, you can see it over there. It was a great teamwork, and it is still a great teamwork. We were looking for addressing these reductions in tailpipe emissions, brake emissions, and at metro stations. So we needed a partner who can later provide the solution. We have WORD, an association in Switzerland. There belongs a lot of companies, research institutes to that association. They have a long experience in diesel particulate filter retrofitting and looking into that effects and positive effects. So WORD is taking care of the tailpipe reduction. For the brake emissions, you need a brake and you need a filtration. So that's a collaboration between ZF and Mann & Hummel as companies. And for the metro station, that's a filtration device. So that's where Mann & Hummel comes into play with our filtration solutions. The first step is to measure. You need to know what is going on, what is on site, how's the exposure, what is the emissions. So with that, we put into the project WORD, of course, for the tailpipe. And then for the brake emissions, we looked at partners who are very established and who do the measurement equipment. That would be Link, and who have a long scientific experience on evaluating the brake emissions. That's the Institute Utah in Germany, in Duisburg. And we are happy that they joined this call and that they are working on this one. For the metro stations, it was very easy. IDEA in Barcelona is a leading institute on that topic. So we were happy that Teresa joined this call on looking at the measurements, and Cardiff, as well as a research institute, is looking into that emissions at the bus depot. With that, we have some data, but what does it mean? Do we need to do some actions? How will the filters later affect the results? What will it be a benefit for cities? Will it be a benefit for the citizens? So you need to assess it. And that's where citizen science is very important. That's when Intech comes into play. And then we need to look also at the life cycle assessment. So our partner Cenex in Netherlands is doing that. And we have the Institute of Workers' Environment in Denmark, a leading institute that is looking into the overall environmental social assessment. And you will hear more about that in session 2. It's nice to know that, but you need to demonstrate it. You need to see how it really works in reality, in life, if you put it in place, if you drive it. So for driving, we collaborated with bus operators, and I'm very happy that LPP is in this room here. From Ljubljana, we worked with Conaribus in the nice city of Ancona, and we had a great collaboration with city of Valladolid and the bus operating Auvaza over there. It was amazing to see what is possible and what data we could select and what we could do, and proving and showing what the real challenges are and how these solutions work. For the metro, I'm very, very happy, I can't express it anymore, to have the great partner of Metro Lisboa in this one, really taking care of air quality. There's a YouTube video, I think about 5 minutes, about air quality in the city, a great city, and something if you want to go for cleaner air, you should go also to Lisbon and visit the Metro, a great partner on that one. And for the communication, putting everything together, that's why we had Steinweiss as a great partner organizing, and you will see it in this event, how they got the IT, the AV, everything running and prepared. It's fantastic to collaborate. So that's the team. The numbers I already have given. And we structured the project into work packages. Work package 1 on tailpipe, work package 2 on the brake emissions, work package 3. We put a special focus on the sustainability. That's why we have work package 4. And then we have the standard ones of work package 5, communication, dissemination, and as well as management. But we don't want to bore you with these details. That's why we put a different agenda on. I already spoke about the disclaimer, that it's our views, not the views of the EU or of the agency, that we present here. We have the 3 solutions, and to give you a brief overview what they do. There's a great video done in Switzerland on how you replace how you put the filter in place as retrofit part in the tailpipe. It has 95 to 99 particle number reductions, and you can see in the slides that they are working. Let me try if that works. Perfect. That they can do the OEM values are over here, and they reduce the particle numbers, but there is no bad side effect on fuel consumption, and it's also working well for the petrol with the regeneration. We have a type approval in Germany. We've done a lot. You will hear more about that in session 3. For the brake dust, we really looked into how buses are braking in cities, what they are doing over there, how we can get access to the acceleration, deceleration. Link developed a cycle that's for urban cities. That's great to see because it's different what they do on the Autobahn or on cross country. So we looked into different buses. We had the chance to also get access to the CAN bus of an ICE and internal combustion engine and a hybrid bus. So we have great data that we are working with and that we can look, and you see a test rig. We had a site visit over there. It's something that can fill in half of this room here, a test rig, better this entire room. It's a nice device to look into the emissions. We have developed the brake dust particle filter. You can see the ZF brake, and you can see the Mann&Hummel filter part on what it's designed as a retrofit part. So the idea is not to have something that goes on new vehicles. It's something that goes on existing vehicles, easy to mount over there. And that was shown at the IAA transportation. We have done some lab tests. We have done winter testing of Vienna in Finland. So everything was working fine. That was great. And we are ready for a type approval in Germany. So this solution is also ready to the market. You hear more about that in session 3. For the filtration devices, we looked into the air purifiers that were for homes. How can we apply them at a metro station? We did that. We installed them at the metro station. You will hear later from a metro operator that we had some challenges in the logistics and putting them up. Now we know how to do that. It's easy to do. That's a great part of this project, that you learn a lot. And you have partners together that you won't learn if you do things alone. So that's a great result that we have. We also looked into how we can trace them. We did measurements on the air quality. You can roughly see in this picture, the red part, that's where we have higher air particle concentration, and there we have lower particle concentration due to the HVAC system of that station. And if we apply filters, we have even distribution and lower values in the station. That's possible, what simulation tells. To prove that and to see under which condition it works, we had 24 low-cost sensors installed, and we looked into the data, a lot of data, and the analysis is currently going on. So again, a great team event. If you have not visited our website, you can scan the QR code. Look here. We had nice locations, nice partners, good working business meetings, as well as a nice evening events. So with that, I think you have now an idea what that project is. It's about collaborating together, doing something that you can't do alone, but driving for cleaner air and bringing solutions to the market. Solutions to the market, they need a regulatory environment. They need someone why you need that. It's not only because they can reduce something, they can work. And with that, I would like to introduce our keynote speaker, Francisco Ferreira. He is a director of Ceneza Nova Institute and the Research Center for Environment and Sustainability. Okay, that's a great title. He is very engaged in air quality. He is in the advisory board of AeroSolfd, and he is a president of a non-government organization, Zero. And he has attended meetings of AeroSolfd advisory board, but also the on-site meeting in Lisbon. Very active, and we are happy that you are here, Francisco, and that you are giving us a quick introduction to the challenges of the revised EU Quality Directive. The floor is yours.
Bon dia, buenos dias, good morning. Thank you very much, Martin. Indeed, I will try to compact in approximately 10 minutes how important it is to actually look at air quality during the next decades. We have a huge challenge because the European Union Air Quality Directive from 2008 was recently revised. And the challenges that we have to reach the much lower concentrations of different pollutants will be huge, from technologies to be applied to the role of municipalities. We do have ahead a future that is going to be really hard for us in terms of work everywhere in Europe. So we're talking about this, and I like to show this picture. We talk about this small layer called the atmosphere, where we actually depend upon, and the quality of the air that we breathe at every moment is absolutely decisive for our health, and also to the ecosystems and the ambient in general. So, as I said, we have a new directive, and that directive came out in 2024. It's Directive EU 2024-2881 of the European Parliament and the Council. It replaced basically two directives where we had concentrations for different key pollutants that have to be applied throughout Europe. And the challenge now is because we're looking at new guidelines from the World Health Organization. The WHO in 2005 set a group of guidelines, basically looking at epidemiological models, looking at what would be the safe concentrations for the different pollutants in terms of cost benefit for health and environment. And those guidelines came out in 2005. But with a lot of studies that were developed from that year upon to now, in 2021, new guidelines were issued. And those guidelines are, in many cases, they actually put the annual concentrations, for instance, in 1/4 of what were the guidelines in 2005. And at the same time, in December 2019, the European Commission launched the so-called European Green Deal. And within that European Green Deal, looking at climate action, with the new targets for 2030 and carbon neutrality by 2050, this European Green Deal mixed issues from biodiversity, circular economy, renewable energy, but also it looked at zero pollution action plan in different areas, in water, in noise, in air. And what is this goal of zero pollution under the European Union? It's basically to try to match as soon as possible the WHO, the World Health Organization guidelines. For you to have an idea, in the European Union plus the United Kingdom in 2022, we have approximately, we estimate 240,000 premature deaths attributed to the pollutant that has the highest impact in terms of health, which is fine particles, PM2.5. Most of these deaths are caused by cardiovascular disease, such as heart attacks and strokes, and respiratory illnesses, including COPD, pneumonia, and lung cancer. And of course, we also have a huge cost in terms of morbidity, besides the premature deaths. So, what are the main air pollution sources and pollutants in Europe? Road transport, definitely. If you actually look at developing countries, in that case, there's also a considerable weight of indoor air quality problems. But in Europe, it is the ambient air and particularly the road transport from internal combustion engines of vehicles that play a major role, while we do not have a transition throughout the next decades to to electric vehicles. But also we have biomass burning in many cases that plays an important role, and also some industries that continue to emit pollutants that are quite damaging for health and environment. So if we have to focus in Europe, what are the main pollutants? We talk about particulate matter and looking specifically to fine particles and respirable particles, the so-called PM2.5, so particles with aerodynamic diameter below 2.5 micrometers, and PM10, in that case is 10 micrometers. But we want to focus on the smallest ones that are the ones that go through our lungs and into our body. Then nitrogen oxide, NO2, and then ozone, which is a secondary pollutant. So it's not the good ozone of the stratosphere, it's the ozone that during the summertime with sun, with the radiation, the sun radiation and what we call precursors actually promote high concentrations of ozone. So the challenges are basically the limit values. As I said, the WHO wants to look at 1/4 of what is the current legislation, but it will go into a two-step approach. So up to 2030, we are going to have to reduce by half of the current values. So, for instance, to give you an example, in PM10, we currently have an annual limit value of 40 micrograms per cubic meter, and we are going to consider 20 micrograms per cubic meter, with numbers already to be achieved by 2026. So an intermediate level that will push the countries to actually implement measures if they cannot reach those limit values. And also we will need to develop roadmaps and plans, including policies and measures to do this reduction of pollution by 2030 and then following it up to 2040. So my final keywords are basically this idea of a zero pollution objective, strict pollutant limits. We'll need also enhanced monitoring and modeling. We have to include emerging pollutants. That's what is also in the directive. But we need citizen empowerment and legal rights in different countries to actually push to this implementation. And as I said, the directive itself has a periodic review mechanism that will allow us to reach this goal. So the project that we are here discussing today is going to be, of course, one instrument with technologies to be implemented for us to get into this challenge that we have ahead of having a lower number of premature deaths and morbidity during the next years. Thank you very much.
Thank you very much. Thank you very much for giving us the big picture and the framework of what this project can contribute to, and that it is about the cities and the citizen science, the people that can drive it and make it happen. And that's something interesting. Product development often is for customers, but these customers are also citizens. And they have also some general needs and something else. And what else they have, this is part of what the citizen science can tell us. So I'm very happy to give the stage to Francisco, a young researcher from Intec. That's also a nice part of this project, that people are doing a PhD on the project and getting into the community and getting into and working or a master or whatever. It's fine. Education is part of this one. And Francisco, the floor is yours for interesting presentation and insights. We're looking forward to it.
Hello, everyone. Thank you so much for coming, for being here today. I'm not doing a PhD, as Martin said, on this matter. I'm doing a PhD in culture and communication. However, I was involved in my bachelor's degree with this project, and it was a very interesting project to really understand the effects that particulate matters have on health, on human health, and overall. Now, to start things off, I'd like to share with you our insights of citizen science. This work was made in collaboration with Dalila Antunes, who unfortunately was not able to be here today. She helped me a lot to do this work. Sorry, I'm a bit nervous. It will pass. Oh, apologies for that. So to start things off, we did a total of 9 interviews with several stakeholders, NGOs, authorities, and experts that are relevant for the area. Our aim was to give more visibility to less visible issues, such as health risks arising from air pollution, as well as consult the stakeholders representing the entities I just referred to. We also wanted to understand what were the main concerns regarding the project. It is essential for there to be a proper communication with the public, because the public is not very aware of what particulate matters are, and they're not very aware of the impacts that it has on human health, because particle matter, more specifically PM2.5, is not visible to the naked eye. And when something is not visible, the overall public tends to not perceive it as a threat. However, it is a very big threat. As Francisco Ferreira referred, a lot of people unfortunately die prematurely due to these particles. So we really wanted to approach people in a way to understand what their position about this matter was, and to effectively show them and introduce them to our solutions as a way to mitigate and combat air pollution. When it came to we actually, in the interviews, we identified several barriers, such as maintenance interference, as for several of the bus companies that we interviewed, about 3, there was a problem with, there wasn't a problem, there was, people thought that introducing new solutions could increase maintenance interference and bring new problems during the maintenance process. There was also some third-party implementation challenges, meaning that for municipalities, it would be better for them to actually implement the solutions within the city, apart from third-party private companies. And also, there could be some driver opposition, more specifically to the tailpipe retrofit solution, as well as to the brake dust particle filter, if these effectively decrease vehicle performance or increase maintenance, which hasn't been the case so far, fortunately. There are also some regulatory and certification challenges. If a lot of automotive certified authorities like TÜV in Germany and Austria and, for example, EMT in Portugal are strict on their measures, and sometimes they could not certify these solutions. Again, not the case. This was certified in Germany by TÜV, if I'm not mistaken. So there's also another problem. A lot of bus companies, their bus fleets usually are newer, and being newer, they have a manufacturer's warranty, and this warranty can be voided if any modifications to the buses are made. So this was also a problem that was presented by the bus companies. Also, there is a problem about awareness and sensitization. An example I could give you, we interviewed CCDR, which is the Regional Coordination and Development Commission of Lisbon and the Tagus Valley. And they told us that they have a major problem talking with municipalities and other entities to tell them the problems that PM 2.5 have. Most of these municipalities and entities are mostly focused on PM 10, and they tend to diminish the importance of PM 2.5. And this is seen as a problem. Last but not least, a lot of suggestions were made, such as financial incentives to adopt the solutions, regulatory framework to adopt the solutions, make it mandatory to implement in cars. For example, the particle filter, similarly to what was done with Euro 6C in 2018, and also if this is not the case, push for higher taxation for cars that do not have these solutions. For vehicles that do not have these solutions. It was also mentioned that more specifically again to the tailpipe, especially this was mentioned by NGOs, that this could be extended to diesel vehicles without DPFs before Euro 3, if I'm not mistaken. And also there could be an extension of low emission zones and ultra low emission zones. In my country, Portugal, it would be a necessary thing, considering that the lowest emission zone that we have is for vehicles before 2000. Those are the ones that cannot enter the city, which is not ideal. Now, moving on, we also did a citizens' risk perception survey on air quality. We divided in several categories. I'm not going to show you every single graph because it was a long survey. However, I'm going to give you an overall understanding of the work that we did. To start things off, we wanted to understand how did people perceive. Oh, before that, I apologize for this. Our demographic was 147 participants. 69 were male, 77 were female, 1 identified as other, and the majority of nationalities was Portuguese. The second one being Austrian with 5, Portuguese 127, the third one being Italian with 3 people, and the fourth one being German with 2 people. So you could think that the idea that the perception that people have could be more on a Portuguese stance, but a lot of the people were younger as well, and younger people tend to have a more European point of view overall. So to start things off, the majority of respondents perceived municipal air quality as good or above. And overall, particles emitted by transport were effectively viewed as problematic. This is a risk perception graph. The lower value, 1.14, reflects effectively low lower risk perception regarding fine particle impact on individual and social health, the highest number being 7 with a very high risk perception. So the risk perception here is moderate to high, with values being the highest values being between 4.29 and 6. Moving on, we also have problems how the fine particles affect people. It was deemed as negatively. A lot of people deemed this as being very negative. But when this question was asked on a personal level, like you see here, and on a familiar level, the graphs are very similar, people tended to be, in psychological terms, this is not an unexpected finding. People's minds tend to pursue a more protective effect when answering these questions. So the answer, although it says affected, on the scale of the graph, it is a more neutral answer due to the things I just mentioned. Moving on, not surprisingly, there is an overall pattern of distrust regarding the government's commitment to reducing fine and ultrafine particles. Nowadays, this has been increasing even more, at least with, for example, in my country, in Portugal, this tends to happen a lot. It is also related to a variety of other things, but yes, it is an important matter. There is also a perceived notion that politicians lack commitment to address particle emissions in the municipality. I'm moving a little bit fast because I only have 8 seconds left. Most participants also, if you don't understand anything, feel free to interrupt me. Most participants also view little commitment to air quality improvements, in particulate matter reduction, and around 74%, moving on to the AeroSolfd Solutions, around 74% of respondents indicated an overall positive attitude towards AeroSolfd. There is a general positive perception of AeroSolfd Solutions on municipality image impact. I'm almost finished. However, about 42.7% of respondents have a neutral stance when asked about their overall perception. The largest proportion of respondents have more positive attitude toward air quality improvement in cities, and about 95.5% of participants evaluate AeroSolfd Solutions as highly relevant. I'm not just reading this, I will explain it afterwards. About 92.4% consider air quality as very relevant for the well-being, and 88.5% state that politicians should be more concerned on improving air quality than they actually are. Main findings. So, as you can see, the lower the attitude towards municipal air quality, the higher the risk perception, the worse the attitudes toward transport particles, and the higher the need towards improvement of air quality. There is a clear perception of political action, of lack of political action in improving air quality, which is a problem that needs to be solved. And just a quick side note. On the satellite event that we did, the only representatives that we could not have were from political point of view. They showed no interest whatsoever. And that is a problem. However, people do perceive the solutions as positive, but further action is needed to improve urban air quality. Regarding the solutions themselves, because this was the first time the population of the survey was introduced to the solutions, they tend to have a more neutral opinion about their overall understanding of them. However, and being more cautious and responsive regarding the project. With this done, I've passed my time. I apologize for that. Thank you so much for listening to me speak. If you have any questions, feel free to ask them. I'll be more than happy to answer.
Thank you very much. Very interesting insights. And also, you can take a water over there. And also some opportunity, as time was short, to raise questions. So you can raise the questions on site on Slido that you can do, but we will start first with a panel discussion that we will do. So I would invite the speakers, Francisco, to take a seat over there, and we will have other people joining. So other people joining for that session. We have Lars Larsen, he is president of the Word Association. You heard the member in Switzerland who's working on the tailpipe and has experience in retrofitting diesel engines. And we will have the collaboration with the Ideal Cluster, and we will have here the project K-Health in Air, Jose Famoso from Cardiff, who is the coordinator of the K-Health in Air project. Jose, it's a pleasure to have you here again. You have been here for the Metro Air workshop and to come on stage for this one. There's water, there is a microphone you can talk in. And I would like to ask the first question to Jose, as this is a collaboration with another project. What is K-Health in Air doing, and how does it relate to air quality and health?
Okay. K-Health in Air is a project, one of the projects joining forces in the topic trying to relate indoor air quality and health. Okay, I think now can you hear me better? Okay.
We can hear you well.
Yeah, we are in the topic working on relating effects of indoor air quality and health, and we are evaluating different type of scenarios and settings and analyzing the indoor air quality and the impact that could have on health. And our main mandate is try to identify if there are some determinants in the sense of the key pollutants that could be affecting in this particular scenario or setting to the people's health, according also the type of people profiles that we can find there, and also try to identify this determinant, the potential sources, and also to propose some potential measures, technologies, or whatever. Some of the scenarios that we are studying within our project are I will start with a metro station, but for sure we are trying to cover another parameters apart from PMs that maybe it's a great insight, or we will get, or we are getting very good outcomes from your projects, both AeroSolvd and Beta projects that will be used, or we will be using your solutions for sure. But apart from the metro station and studying PMs, we are also evaluating another parameters that could be also be relevant in this particular scenario, like microbiome, volatiles, radon, also in some of the scenarios. Okay, and apart from the metro station, as I said, we also are studying scenarios like city market here in Valladolid also. 2 hospitals, one here in Valladolid and also in another one in Rotterdam. We are also studying schools in Poland and Austria, homes in several countries, Poland, Austria, Rotterdam, and here in Barcelona again. Also, and canteen, a lecture hall. So well, you could see that we are studying different type of scenarios in order, or settings, in order to identify these potential determinants that could be affecting the health. And just to highlight that, these pollutants should be keep in mind, because in some way, indoor air quality in many of these scenarios are invisible until now, and we are trying to identify them.
Yeah, and you make them visible with a monitoring campaign with low-cost sensors that we also used in AeroSolvd. Yeah. Things being visible, not visible. The diesel engines. I'm looking at Lars from Word. Why did it start with diesel engines first, and why was air quality retrofitting going for diesel engines first, and petrols are coming late now? And you can introduce yourself as well.
My name is Lars Christian Larsen, and I'm representing the International Word Association from Switzerland, which has been involved with particle filter retrofit and emission control technology, mainly for diesel engines in the past. The answer to your question, and you asked me to be short, Martin, is I don't know. But if I have to elaborate a little bit on that answer, we have all historically been aware that particles are bad, and particles were emitted from diesel engines. And therefore, we did something about it. We introduced retrofit of particle filters for on-road and off-road since 20 years ago. And then in the meantime, all diesel engines on passenger cars, off-road equipment, and trucks and buses and so on has now been installed with a particle filter. Particles are bad, but recent research and investigation have also proven that the smaller the particles get, the more toxic they get to the human body, because the biggest particles are captured in our respiratory ways, but the smallest particles, if they are small enough, is carried all the way into the lungs via the alveoles into the bloodstream. And in combination with that, you have a lot of toxic substances attached to these very small particles, and then it really gets tough on the human body. The answer to why we have not focused on particle emission from petrol engines, because they are so small that we have been incapable of understanding and measuring and quantifying them. But recent technology steps has also made it possible for us to measure them and actually quantify how many particles is actually emitted. And the conclusion is that even though we were of the perception that diesel was bad with particles and gasoline was fine, we actually figure out that now particle emission from petrol engines may be even worse than diesel. But everything Francisco just said you should not believe, because particle matter is of no interest when it comes to emissions from a petrol engine, because there is no mass. Mass is minuscule. The quantity is what's important. And that's why I'm here to defend the argument that we need to move in a direction where we develop methods and science around proving that very small particles are the most important thing, and that particle number is the measure that we should be focused on. And particle number is what's relevant for the petrol engine.
With that, I'm looking at Francisco Ferrero. You said that framework, the new directive, and PM 2.5, the values are much lower now that can drive the solutions. But what about PN? Is that somehow getting in focus in the EU and the directive? Is that a way to look forward?
First thing is that I fully agree with what Lars just said. And the directive includes that the issue of ultrafine particles, for instance, and look at particles into a deep dive in the effects of health. and indeed, I think it was very important to start with the diesel cars, because the issue of particles really got into the not only the eyes of the people when they looked at the smoke coming out of the engines, and now it might become easier to talk about also the gasoline cars and the effect of particles. So I think that within the three pollutants that I talked about, NO2, ozone, and particles, if you compare the health effects, it's a huge difference in terms of with the others, and indeed we need to focus on the challenges that we have ahead, particularly in the cause of these particles. And when we look at road transport, you look at a lot of countries, for instance, in Portugal, most of the cars that are now being bought are gasoline cars. So basically, you decided to move away from diesel. You're starting to have electric cars, but the largest percentage now is gasoline cars. And if you don't have the tools to actually have in the medium term a focus on counting the number of particles in the inspections, if that is not an issue also under the Euro norms, if you do not have also technologies to be applied to this new new amount of combustion engines in the new cars, you will not be able to look at the reduction necessary of PM 2.5 and eventually of the very small particles that we have in the air, and as I said and as Lars said, are the ones that have the highest impact. So in summary, I do think that this issue is an issue that is in the directive, where we need to look deeper to have solutions, targets, and options. And the revision by 2030 or after 2030 could actually include these new insights that we have from what is happening now.
To remind you, if you have questions in the audience here, just raise your hand and there will be a microphone coming to you. If there are some online, we can ask them. But I would first go to Francisco Nobre again about the citizen science. The insights were, for me, a little bit in the city, they want some action. The citizens want air quality. They also want that there is something happening because they think it's a threat. On the other hand, they go back and say, wait, it's my family. I'm protecting my family. Everything is fine. Mm-hmm. Can you comment on that? And what could be a solution?
Well, in cities, it's normal to have that perception. On a satellite event we did where Francisco Ferreira talked, he mentioned that Avenida da Liberdade, which is a major avenue in Portugal, is one of the most polluted places in the city, and it is essential to have solutions like these ones to effectively decrease pollution or mitigate the effect of pollution. Now, regarding that aspect, I believe that people do not, overall, I'm generalizing, but people don't really like to be confronted with things that really affect them, affect their health, and most importantly, their family members' health. I think, again, as I was trying to explain, this really does explain the sort of neutrality on those answers, because these people know for a fact that pollution exists, that it's something that needs to be fixed. However, but there's my family members. I don't want my family members to be hurt. Maybe I'm just going to be a little bit cautious with this. And not just that. I think, for example, for the retrofit tailpipe filter, when you introduce this solution, the fact that you tell them that it's going to cost X or Y or Z, whatever, there's also a tendency to retract a little bit from wanting that solution because they're going to have to pay extra. I also think that is an important point of view regarding this.
That creates some thought of, if you look at questionnaires, if you are staying at a hotel, if you are staying at a car, renting a car, there often comes one question at the end. How happy are you with it? Rank it on 1 to 10. And then sometimes, would you recommend it to a friend? Mm-hmm. And that's, I think, is somehow the way of, I'm not doing my personal because I think I'm fine, I have done everything. I recommend it to someone. Have you some experience in the citizen science about asking that questions? Would you recommend it to someone else, or would you recommend it doing for some and then you get more support?
I would definitely recommend it to someone else. If I could, I would use it. I can give you my personal example. I own a diesel car before Euro 3, so it didn't come with a particle filter. We did some fixes for it to not pollute that much because it was releasing some black smoke. And no, I'm not being an hypocrite on this matter. And I would think that effectively a solution like this is essential for people to keep their old cars if they want to. Because in Portugal, and I think Francisco is aware of this, people tend to be a little bit stubborn. And they really like their cars and their old cars. When you tell them that they cannot go to the center of the city because their car pollutes, because of something that they don't see, an emphasis on the commas, they get mad, they get annoyed. Oh, I can drive my car to the city. Why? This is ridiculous. Blah blah blah. Whatever. And I think solutions like this one are essential to effectively communicate to people that this is a problem, and they could keep driving their cars to moving on to an electric mobility at the end, being a transition to electric mobility. And I think it's important for that. That's one of the reasons I joined the consortium. It's because I think that, for me being a car guy, I think that solutions like this are essential in the long run, or maybe in the short term too. Yeah.
So you're addressing that the valid point of we are going to transition zero pollution to electric mobility, and there are still people who want to drive their cars. And I'm looking at Lars, but if someone else on the panel would like to step in, that's also fine. You can start the discussion and raise your hand.
Can you go first?
I think we, as an association working with combustion technology, we are fully aware that we have started a path towards electrification of a large proportion of our fleets. But we have to remember that the fraction or the level of combustion engine technology will still be growing by mid-2030s. So worldwide, we will still have, for a decent amount of years to come, a lot of vehicles running on the roads without a particle filter. And the product that we have provided through the AeroSolvd program is something that is a good and cost-effective tool to actually keep some of the vehicles longer on the roads that we will allow elsewhere without a particle trap at a reasonable cost. And I think that's important, because that was one of the main objectives of the AeroSolvd program. That was, guys, do not come up with a weird and wonderful solution for X amount of hundreds of thousands of euros, because that will never materialize into anything. You have to come up with something that's TRL8, something that's off-the-shelf available product, and at a price that will be compared to less than 10% of vehicle value. And that's why it is a cost-effective solution. But I think we will go through that electrification phase, or whatever to come in the future. But please bear in mind that the petrol engines and the diesel engine will be increasing worldwide until 2038, I think. And then after that, the fraction of combustion engine technology will start to decrease. So we haven't even started the descent of the petrol engine yet.
Go ahead.
Just abunding a little bit on that idea and the concept of scenarios that we manage in the indoor air quality. We also, from my point of view, we also think about the where we are going to move the cars. Maybe we can move faster in very crowded spaces, like very large cities or whatever, and moving maybe faster through electric vehicles, but maybe not for all the parts. And these kind of technologies, from my point of view, should support in some way that the transition could be a little bit slower, not so imposed that we are seeing today. Because yesterday we were discussing about when we thought about the pollution and the impact on health, we could see that it's clear that some thresholds should be respect, and in some way we are just propose some politics to for different levels of particles, but also nitrogen dioxide, whatever. But when you're a politic and you have to generate a new politic, you have a lot of things in mind. And we are discussing, we were yesterday talking about that. At the beginning, during the project, I saw that it's clear that we should propose some thresholds, But now we realize that this is not so easy. And we have an example here in our city, in Valladolid. We have a very large car factory. Renault is there. And the reduction of, the implementation of these policies for fostering electric vehicles is affecting in some way the factory, the city, and this kind of dynamics should be also keep in mind. And these kind of solutions could be very useful for maybe make a softer transition to these new types of mobilities that for sure will be good in future. But I think that this I'm not an expert in social science, but for sure we should keep this in mind in order to transit better.
Just to add one important thing, which is according to the directive, we have goals for 2026 already. December 2026, we have a target to reach in terms of PM 2.5, PM 10, okay, and other pollutants. And if we do not reach that level in the different cities, we have to implement plans to improve the air quality, and those plans have to have different policies and measures, including some that are more behavioral, or some that are more technological. And of course, I think that under a car fleet that has still a lot of combustion engines, the different cities, if they do not comply with the limit values, they have to include issues like particle filters for the cars to actually reduce the concentration of particles. It's not going to be the solution, but it's going to be part of the package for sure to reach the levels they have to assure by 2030. So it is really a short-term measure, I would say, in order to comply with the limit values of the directive by 2030. And then, when the directive is revised, probably to lower and reach the World Health Organization guidelines in the future, you have to again revisit those technological measures to be implemented.
Martin, we have a question from Slido. So can I pose it? Yeah. The question is, are European cities prepared for retrofit solutions, and are they interested in them?
So the retrofit solutions are there. If cities want to implement, is there an infrastructure? Can that happen? Last, you have experience with a diesel particulate filter. How does it work with that retrofitting? If a city wants to do it, who does it?
Yes, the joy of retrofit is that it is depending on some kind of regulation. That regulation being mandatory schemes in the terms of low emission zones or funding. When that happens, there will grow an infrastructure to support it. So that means somebody who can manufacture the filter, that one is ticking the box because this filtered component, which is the key, is actually already in the market for new vehicles. Then you have the integration and the design work and the installation on vehicles. That is an infrastructure that will grow. But the problem with retrofit in general is that if it's only sporadic systems that work for 1 year there, 1 year, and then in different regions, it's very difficult for the industrial structure to adapt. So that means if you build up capacity for one region and the program lasts for 2 years, then you're left with no business after 2 years, and then it kicks off in another place. So that's why regulation Europe-wide is quite important to establish a business model for the people who actually supports the retrofit in terms of production, design, and installation, to make sure that you have a reasonable forecast of your business. Otherwise, the infrastructure will not be there to support it. If there is some kind of certainty, it will be there because it's a business like any other business.
Yeah, but looking at the retrofit solutions for diesel, it started in some smaller paces. and then it came. So the solutions, and that's the beauty of AeroSolvd, they are developed, they are there. If someone is pushing and starting, we have seen that in the video, it's easy to retrofit. So a start can be done for pushing up it across Europe, and for the business dream. Yes, there is more regulation needed. And looking at Francisco Ferreira again, we have now a solution. We have also citizens who are looking into that topic and saying, oh, it would be nice to recommend a solution. We have the directive that's forcing the cities. How does non-governmental organizations like Zero come into place, and who can be the one that drives this to get the mayors and the politicians? No, that didn't respond, as you said, to the survey. No, here is a solution that helps to make citizens happy and solves your directive problem.
I really think that it depends from country to country, because let me give you the example of Portugal. Who is responsible for assuring that we reach the limit values from the directive? It's basically the government. It's basically the Portuguese Environmental Agency that has that competence. But who is supposed to implement? And here we're basically looking at regional administration and then the municipalities. And what has happened is that since some of these measures are not within the Portuguese law, they are not compulsory. The government suggests policies and measures, wants to apply policies and measures at the regional level or at the local level, but then the municipality says that it's quite difficult, it's not viable, it's too costly, of course. And that's the reason, for instance, we have a low emission zone that is not updated since 2015. So I really think that the role of NGOs have been to push both the government and the municipalities to implement the plans that in many cases are already defined, where the measures are already there, where we know what to do, but it is not done. So, and we do that through press releases, we do that in actions in different cities. And that's not only in Portugal, I believe that is everywhere. So I think that we need a mixture of the willingness from the government and the regional and municipal institutions, with the involvement of NGOs and civil society to actually implement the answers that we now have to go through.
I think that's a great point to say that we have that topic in session 4, where we will look into that in more detail, what the next steps can be. I see a question from the audience. Let's take that one here. Please state your name and...
I'm Christoph Asbach from Utah and Duisburg. It's more a comment than a question. Francisco, you mentioned that we need to have kind of press releases, inform the governments about what is needed. I think what has not been sufficiently done in the past is we need to inform also the general public. We need to raise awareness on both the health effects of air pollution. Certainly, I guess the general public has some diffuse understanding that air pollution is bad for our health, but they don't really understand, and they probably don't need to understand the details, but they need to understand that better. But they also need to understand, and I think that's from the other Francisco, you had a nice slide, and that's probably a trend in our societies, that it has become too easy to blame the government for everything. We need to understand that we are currently we are the polluters, right? We're currently more part of the problem, and we should try to involve the people more to become a part of the solution for this problem, and not make it too simple to just blame the government for everything. There are enough reasons to blame our government, certainly, but I think here we need to get make sure that the citizens get involved more in becoming part of the solution rather than remaining part of the problem?
I think it's kind of a shared responsibility. So you have to push the government and you have to involve and actually make the public understand why those measurements are necessary. Because in many cases, the municipalities do not act because they think that the public is against the measure because it is costly, because it's complicated. So you really need to get to have the public awareness to actually know that those measures are essential for their own health. And of course, when we do a press release, for instance, is indeed to pressure the government, but is also definitely to involve the people.
Martin,
thank you very much for that.
Could I add something very quickly? Or there's no time?
You can do that quickly, very quickly.
Very quickly. I think we should also talk with mechanics and mechanics associations, because in the example of Portugal, there is a tendency, at least for diesel vehicles, to remove the particle filters because they, over time, tend to clog the engines, whatever. A lot of the cars in Portugal have upwards to 300,000 kilometers. They're 16 years old, 16 years older.
You're bringing up a very good point, and that will be part of the technical presentation of session 3, where we talk about the dirty tailpipe that you will later know.
Martin.
No, that's fine. That's great. You're doing a commercial for why you should attend our session 3 after the lunch break. But before the lunch break, we have another session, and that's exactly adding to why we should do that, how we should do that, how we give cities some ideas what can help. I would like to thank the panel here for giving us the insights on why air quality matters. You can use this one for the applause, or you can use your hands to give an applause to the audience. Panelists, thank you to the panelists. And we now move on to the second part of that's also addressing the cities, because we are giving the government and citizens an idea what can be the effect. It's a session that is, for me, somehow the core of the project, to put things together, to combine it. And it's a pleasure to have the colleagues here working on that. And for me, it's a very nice session, because I don't have to moderate this, because we have a enthusiastic person on this topic, on sustainability, on air quality. Ute Bock is in our advisory board. She had given us very great input in the advisory board meetings, and I'm happy that she is here, and she will take over and guide you through this session. And yeah, sit back, relax, I would say, in an airplane. No, get engaged, ask questions later on Slido, and follow the session. Ute, the floor is yours.
What a great introduction to come up stage, so enthusiastic. Yes. The project was about how can we take action, what can we do, and to be part of this multidisciplinary European project. Real pleasure, and I look forward to introduce Kelt, invite to come up to stage, because it's about how can we make it sustainable. How can we get all the people involved, multi-stakeholders, which was also mentioned here. You're welcome to come up. The first question before you enter was really, what made you interested? How do you want to time? Because you have got multiple disciplinary approaches also, what I saw in the research.
Yes.
Say?
Yeah.
Come up.
Yeah, thank you very much for the introduction. And yeah, my motivation to move into the AeroSolfd project is lying on, first of all, we know that the ambient air pollution has been an issue, and for way more than 20 years, we knew that traffic air pollution was a big contributor to the associated health effects we see in people. And at the same time, we've been working on aspects of risk innovation governance for me for nanomaterials, and some ideas about sustainability assessment and safety by design is developing there, and we thought it could be very interesting to take this view and aspects of sustainability assessment into this project, and luckily Martin agreed that we could do that, and also target questions regarding the Green Deal that was mentioned before. Yeah. So I guess we need to move on. Yep, here we are. So this is our session, Benefits by Retrofitting from a Life Cycle and Overall Sustainability Perspective. I will be talking first about our objectives and the roadmap for our assessments in AeroSolfd. And here I think it's important as a start to know that even though we have products that are beneficial, there is a fundamental rule basically that you cannot do something without causing potential harm or damage on other aspects. So we know we cannot produce a product or a product without using materials, without using energy, and that's also associated with emissions. And in principle, we need to look at the overall balance to see what we get out as a product and its function. Is that in balance or improving the overall situation regarding pollutions, health, etc. So the impact might be on human health, it might be on the environment, it might be on the society, it might be on economy. So there are different aspects to look into. What we've done in this project, we've been looking into the here we are. I cannot find here. Okay, I just point lower than that. So, okay, anyway, I'll not use the pointer. So we have used different procedures to look into these aspects. So we look into the social life cycle assessment, where Francisco has already presented a little bit about that regarding the public perceptions. We'll do an environmental life cycle assessment, and then we try to combine it all into an overall sustainability assessment. So the social life cycle assessment is about to identify the social drivers and barriers for implementing the retrofit solutions. The environmental life cycle assessment is about quantifying the energy and mass flow impact on environment and human health, using a standardized approach for this assessment. And finally, we try to combine it all into the overall sustainability assessment, combining the social and environmental life cycle assessment, and then we try to add on with additional risk assessments on, for example, the pollutants, and also try to evaluate a little bit on the economic impact and societal cost. So the process we've been through is to, first of all, scope the analysis. We need to figure out where were the exposures and the releases during production and use, and potentially also during the recycling and waste in the end. We identified the sustainable development goals and setting the system boundaries. Then we did the social LCA with model developments and interviews and surveys, and conducting the analysis. And then the environmental life cycle analysis, we also had a model development. We had to establish a data inventory to be able to do the assessments and then conduct the assessments. And finally, we do this integrated in the overall sustainability assessment with specific risk assessments and integrated sustainable development goal assessments. And along this line, we are also in the line of progress in work. So the first parts are complete or being completed, whereas we are in the process of doing the overall sustainability assessments, but I will talk a little bit about this also later during our session. So then I will bring it over to Francisco Dobra to take the next talk. Sorry for taking on your job.
No, it's all fine. Just to share, well, it's a pleasure to introduce Francisco again. He was the one that interviewed me whether I'm the right person for the project. I'm very happy I was approved. And so, welcome to stage again. Come on. Let's go.
Hello once again. So I'm going to present to you the social life cycle assessment, some of the social life cycle assessment insights we got, present you some of the indicators as well as some of the results we got. This was a mistake. Right here, the indicators we developed were based on the pilot projects on guidelines for social life cycle assessment of products and organizations from 2022, and also the PSILCA database, which is the Product Social Impact Life Cycle Assessment database. We wanted to understand in the manufacturer's survey what was the life cycle, what were the social impacts of the life cycle of the products, of the solutions. And so we developed questions ranging from raw materials all the way to health and safety to really encompass the entirety of the production cycle. Moving on, we also decided to develop new indicators for this manufacturer survey, both being usability and usefulness. For usability, we wanted to understand how easy it was to, how easy it was to assemble the solutions, how easy it was to replace the components of the solutions, how easy it was to ship the solutions on an international level, as well as the ease and frequency of maintenance, and last but not least, the ease of disposing or recycling components replaced during maintenance. For usefulness, we wanted to understand the impact that the solutions would have in the companies developing them, as well as the strategic value that management would attribute to them. And again, last but not least, we wanted to know what were the benefits that that the manufacturers perceived while and how they evaluated these benefits. We also developed a survey for drivers of the tailpipe retrofit solution for testers. And it was similar in the sense that we had usability and usefulness. However, this time we wanted to know how much time they had to wait for the installation of the retropipe filter, if they got any explanation of how the retrofit tailpipe system worked, and if they were informed about what to do if they noticed any changes while testing the retropipe filter. On the usefulness regard, we wanted to understand how drivers felt using the vehicle after installation, if they felt confident, if they felt proud, if they felt they were doing something good for society, and also understand if there was any change in driving experience. For example, if fuel consumption increased, decreased, if there was any performance increase or decrease. We wanted also to know if they were exposed to the results of the tailpipe filter, and how they perceived the usefulness of the solution from a personal point of view and a societal point of view. And again, what were the benefits that they most perceived. Moving on, for the main findings of the manufacturer survey, we found that the materials, regarding raw materials were mainly sourced from the EU, and it did not require any rare raw materials, which reduces transportation-related environmental impacts while supporting the local economy and supply chains. It also helps to minimize social and environmental risks associated with the extraction of raw materials. Key benefits that stood out from the manufacturers was the standard emissions control, contribution to mitigating global warming, as well as improved air quality. For the brake dust particle filter, again, there were no raw materials or rare raw materials. There were no rare raw materials used, sorry. But there was a positive knowledge sharing on both academia and with partners. The solution was also subject to rigorous safety assessments to ensure compliance with industry standards. and it has a simple usability with straightforward installation and maintenance procedures that require minimal time and resources. For the air purifier, we got the answers a little bit later, so we weren't able to create something more detailed. However, that's not a problem because Tomé or Guilherme, when they will present for Metro, they will explain most of the challenges that they have faced with the air purifiers, I believe. But as you can see here, it was a challenging assembly process, and the size of the solution was both seen as a challenge, either aesthetically, from a transportation point of view. It's not to say that it's a problematic solution, because it is not. It's not at all. It's a very good solution. It's just has some problems that have to be fixed. Nothing out of the ordinary. Okay, this was a mistake by my hand. Ignore what's written here. We had the result. I have the results for the driver survey. The perceived value of some of the drivers were up to 800 euros for the tailpipe retrofit filter. And there was some uncertainty about purchasing, which suggests a potential concerns about perceived value, affordability, or accessibility. They felt no impact on vehicle performance or fuel consumption, encouraging environmental sustainable adoption of this solution. And most of them recommended the solution to others. However, the perceived value of 800 euros, although it is a value that probably couldn't be lower than this, it could unfortunately diminish some of lower income households that would not have access to such monetary means. Yes, with this, I end my part of the presentation. Yes, go ahead. You can speak here.
I come from the outdoor. Which country? Yes, thank you. With many years coming from the automotive industry, when you speak from, we spoke with manufacturers. Where were they?
I was not clear on this end. The manufacturer survey was for Mann & Hummel and for Vert, the developers of the solution. We really wanted to understand if there was any social impacts on the production of the solutions.
I mean, people talk about CO2 footprint. They talk about circular economy and how can we recycle. So that is also give things a second life. Mm-hmm. But I think that might be later on by you also addressed, Carl. Okay, great. Thank you very much, Francisco.
Any more questions? No? Okay.
Not at the moment. So I have the pleasure to introduce Pablo, who comes from Delft, Netherlands. And we really have got the European spirit, I would say. Yeah. You're welcome to enter the stage. That's all good. Yeah? Yeah. And I ask you again, because I read a bit, you worked with City of Amsterdam.
Yes, our company is based in Amsterdam.
Exactly.
Yeah.
So how were you approached by AeroSolfd, or what caught your interest to join here?
Two things, mainly. The first one, that usually all the LCA work that we do is not meant for things that help clean the environment. So you always know that you're going to pollute more. And the LCA basically helps you understand how much. But for this case, the solution is meant to pollute less. So already from the beginning, it was interesting to look a bit deeper into what this solution can bring. And secondly, that indeed it is something that people do not see, and then it is hard to realize what the impact of it is. So we've tried in this work package 4 to bring all of these weird numbers that you can have floating around into something a bit more tangible for people to understand. Yeah. Okay, so I'm going to talk briefly about what a life cycle is. Perhaps everybody here at the consortium already knows what that is. We've been talking about it a lot, but I'll give a quick introduction. Then I'm gonna explain what the difference is between the emissions that you can have and the impacts that these emissions have. And then we'll look into the retrofit solutions. So basically, life cycle assessment looks into three main phases. The production phase, so that looks into all of the bill of materials that you have, basically all of the raw materials that you need to manufacture your product. And throughout that process, you have emissions, so you have waste, you have energy demands. Then we move on to the use phase, so when you're actually using the product. In some cases, you still need energy. In some others, you don't. For the AeroSolfd example, you don't really need energy for the brake dust filter and for the tailpipe filter, but you do need it for the air purification filter. And then we look into the end-of-life processes. And you just mentioned it a minute ago. Then what happens after you've done using your product? Do you recycle it? Do you burn it? Do you just put it in a landfill? And all of that adds up to an environmental impact that eventually also affects human health. So what are all of the emissions? Well, you have several emissions. There are a lot of different compounds that you will release into the air, but some of them are actually also released into the soil, and some of them permeate into the water. And all of these have environmental impacts. So we can actually look into 17 different environmental impact categories for the AeroSolved 3 solutions. Not all of the 17 are relatable, so not the products do not have impact on all 17 categories, and we focused on the ones where the solutions actually have an impact on. To be able to conduct the life cycle assessment, we need data. And that is always a struggle, because it's not always easy to come by. Even if you are the manufacturer, the data that sometimes we ask for, it's not easy to get. But something important to know is that the data that we have, either from the data that we receive from partners or from our databases, we need to focus on the spatial resolution. So it is not the same if you build your retrofit solution in China or in the US or in Europe. And also we need to localize the emissions, meaning within the manufacturing phase, you may have certain regulations and a very localized area in which the emissions are being released. But for the use phase of the aerosol filters, yeah, they're going to be in the cities. So the impact that it will have on human health will be potentially higher, if higher in the good way or in the bad way, depending on what the results show. So it is important to know basically what, where, and when these emissions are being released. So, for example, taking the brake dust filter, you have emissions to air, and in this case, you have all of the disc brake that is wearing out, as well as the disc that is wearing out. So you have several compounds that are released into the air, and some of them you cannot see at all. The LCA allows us to categorize all of these different compounds and then link it to what the impact they would have on the environment and on human health. So as we can see, the fine particulate matter formation is lower with the solution. So on the left side, you have the baseline, and then on the right side, you have the solution. And you can see also how it reduces human toxicity, cancer-related, non-cancer-related, but also in terms of the ecosystems, how it is actually better to have the filter for species in water and on land. I will come back to this a bit further on, because perhaps these numbers don't really say anything to people. Yeah, you can see how values are lower, but what does that actually mean? We don't know yet. I will come back to this later. This slide, I just realized there is a mistake because particulate matter formation is categorized and charted according to the recipe model, but the non-methane volatile organic compounds are not there. So yeah, this graph is not correct. For the tailpipe filter, you can see a huge improvement in the fine particulate matter formation and also a reduction in human toxicity cancer. Now, we had a few discussions amongst our work package 4 regarding the human toxicity, non-cancer related, as they appear to be higher with the solution. However, we reviewed it with different models to assess the impact. And we found out that the recipe model, which is one of the models that is most widely used in the world, does not account for polycyclic aromatic hydrocarbons in that category. However, if you use other models such as environmental footprint model, that one accounts for them as having an impact. So in this case, yeah, it's also good to know that depending on which model you have selected to run the LCA, some of them, because they have linked it to different studies, some of them say, yes, this compound has an impact on this category, or no, this compound doesn't have an impact on that category. But overall, we can see that the tailpipe filter is actually still beneficial to install. Again, these numbers perhaps don't mean much to you, so I will introduce a new concept, that is the DALI. The DALI basically is the disability adjusted life year. In layman's terms, that means imagine you have a person that will live 80 years. Somebody thought, okay, if this person dies at 70, then there's a 10-year that this person lost. And maybe that person didn't die at 70, but had a disease or had an illness for 10 years. So it didn't have a good quality of life. So it also gets accounted into the DALI. So it looks into all of the years that you've had an illness or a disabled life, plus the years that you lost. And that is the DALI. So to be able to, in short, one DALI is one full year of healthy life lost. So we decided to take all of these environmental impacts and health impacts into what they would mean for human health. And in short, well, this is a bit shifted, but in short, using the brake dust filter for its lifetime, so the lifetime that we assume for the brake dust filter was 100,000 kilometers, which is when it would be replaced. The impact that you have, the benefit of it is 2.38 hours of healthy life that you gain by using the filter. On the other hand, the hours that you gain by using the tailpipe filter is 0.95 hours, so almost 1 hour. This maybe already means something to you, but not quite. What happens if you take Amsterdam as a use case? So Amsterdam has a petrol car fleet of around 200,000, and it has around, the number is also moved, it should be 1,500 trucks. That includes delivery trucks, logistic trucks, garbage trucks, and it has around 350 public transport buses. What does that mean for the trucks? Well, for the trucks, it means that within the city of Amsterdam, on average, they travel 66 million kilometers per year, and the public transport buses, 45. So if we recall, this is for the brake dust filter. So if we recall the 2.38 hours that you gain from each installation, then throughout the year, you actually, within the city of Amsterdam, you would save around 11 days. So that means installing the brake dust filter has a positive impact of 11 days of a healthy life. This is, of course, distributed throughout the city. It's not that each one of you will get 11 days. It's the overall city gains 11 days of healthy life. What happens with the cars? Well, there are a lot of cars and they travel a lot. So the actual impact, the positive impact, I cannot move to a next slide. Okay. I don't know why there's not a next slide, but the actual impact that you have in for the vehicles is 123 days throughout the city of Amsterdam. And I guess my time ran out. Do you have any? Do we have time for questions or not really? Do you have any question?
Any immediate thoughts? No? Okay.
Yes.
Hi, Thomas Wolf, ZF. Yeah, also just a recommendation first. I think it's a lot of numbers. So the question is, who in society understands it? So I must say this. So what's the message to the public?
Yeah.
So that should be a little bit more in the way that everybody understands. We had this discussion before, and I believe the major is to convince the society, and the politicians will follow the society and not vice versa. Otherwise, society will just ignore politics. And that's why they need to understand what you're saying. So, and just the question behind, what's the impact? I mean, you're talking about hours, let's say, whatever, how much the amount is. But if I would say, I have a city, whatever, with 500,000 people, and I save 2 hours for each, so I have 1 million hours saved. So what is the impact for the society in regards of pensions, costs, really? What, I mean, we put money in people to develop people, to train them, to teach them. And you also have an outcome of it. So it would be also interesting to see what is really not only the life cycle. So it's nice to have a longer life, but I could also say that I rather leave Amsterdam if I only get 2 hours. And maybe in the urban environment, I get 5. But for the society, it would be interesting. So what is the cost saving, or let's say the efficiency saving in money even, or something like this?
Yeah, that I think you're very right. However, the economics of it is not something that Cenex did. But I agree. Once you actually have these numbers and you say, hey, you're gonna win, or you're gonna gain 11 days of healthy life, and by the way, this is also the economic side of it, then you actually get a holistic view. But that is something that we are trying to work in the whole sustainability framework. So,
and I thank you for the question, because I think the beauty of the project is as I said before, the multidisciplinary. So you will find answers from help probably for society. What impact does it have? With for me, the evaluation you did was also the various environmental impacts it has with the soil, I was astonished. So what kind of scope did you look into? And then if you present to a city like, where is ZF? In Hanover? Yeah? So if you present to a city of Hanover, you look into what is their pay point? What are they interested in? And the project, from my perspective, can use what the various disciplines to fine-tune it and tailor-make it for what really is a pain point or of interest for the city. Does that resonate? Let's continue in the break.
okay.
May I invite everyone up? You have another one. You have another one, correct. So.
And just to comment a little bit on the last part, that was why we tried to compare with the number of cigarette packages, because that is a well-known, very unhealthy habit to smoke. So that's kind of a reference for what the impact could be. But yes, we will work further towards trying to explain and illustrate what is really the effect and benefits. So I will be talking now a little bit about the impact considering the sustainability assessments. And as mentioned, this is work in progress, so you'll not get a lot of data, but you'll get some considerations on where we are. So first of all, sustainability is a global to local action. There's the UN Sustainable Development Goals that can be addressed in many different ways. And in Europe, they have identified a number of, or basically a number of targets regarding the environmental sustainable development goals. So there's a report setting out what are the targets and an annual follow-up actually on each of these indicators or sustainable development goals. And what we also know is the Green Deal commitment. It was mentioned before in the first session. So the Europe put in a Green Deal ambition with a lot of targets, you can say. One is zero pollution ambition, where they want to protect the European citizens and ecosystems. Where we need to be better to monitor, report, and prevent and remedy pollution from air, water, and soil, or to air, water, and soil, which is very relevant for the retrofit solutions that we are talking about. There's also an ambition that we should accelerate the shift towards sustainable and smart mobility. So transport in general should be drastically less polluting, and this is something we have shown, or you will be seeing, can be done with the retrofit solutions. There's also acknowledgement that this doesn't come for free. There's a need to invest. And it actually requires, what was discussed before, that we mobilize both the private and the public sector in this action. So what we investigated here in AeroSolvd, first of all, was really to understand where can AeroSolvd contribute to the Sustainable Development Goals. And to be able to align with something in a larger scope, we looked into the European ambitions regarding the Sustainable Development Goals for each of the retrofit solutions. And we basically map out 10 different Sustainable Development Goals where AeroSolvd may contribute to different levels. I mean, sometimes it is a very clear one, which we will see on health, and we already discussed regarding health, and we saw on the environmental from the LCA analysis. But there could also be effects on economy and the partnership for the goals, which is really reaching beyond your collaboration, setting up requirements. For example, if you have a production, you want to say that you need to produce under clean conditions. And thinking about the life cycle of cars, they might move out of Europe. So we do not only have a city or European level of reduction, but it can actually translate into other developing countries taking over some of the vehicles in the future. So there are many levels of aspects. Just for you to understand that behind each of these Sustainable Development Goals, we have a number of parameters that we look into. This is, by example, now on the good health and well-being for SDG 3, ensure healthy lives and promote well-being for all at all ages. So we have a part on human risk assessment where we go through different indicators for human health. And we saw one now with the DALI calculations that Papu presented, but we can look into different endpoints, basically healthy life years, DALI as we talked about, but also specific health effects on asthma, lung cancer, heart diseases, etc. And then we have the social impact as also an indicator going into SG3, which is basically the premature deaths due to exposure to fine PM. And then there's an economic assessment that is linked to actually each of these indicators. So there is a positive negative balance in a way. So here we can reduce social cost, for example, by lowering the healthcare for in the time frame where you have a disease. So here we have the most important Sustainable Development Goals that we have identified. So good health and well-being, sustainable cities and communities, and life below water and life on land. And here are some of the indicators that are probably key for understanding the impact. And when we look into where AeroSolvd can contribute, you see in green where we have a clear qualitative indication at this point, and to some degree quantitative indication on a positive impact. So for example, healthy life years, premature deaths due to exposure to PM. On the environment, the same indicators, but we also have plus minus indications regarding the life below water, because we saw for the tailpipe, for the breakware filter, that there was a clear reduction in heavy metals, which has a positive impact on the environmental toxicity. But for the tailpipe emissions, that may not be so significant. We have others where we currently cannot say that we have a change. These are in black. So something we need to look into further with the different assessments, and maybe also running different models, as Pablo was mentioning, can give us further insight into the environmental impacts. And regarding economy, there's clearly a positive effect on reducing health costs. There's also a benefit of a longer life in general if we value a life of each individual. So considering the scale and extent of the impacts, the tailpipe filter will reduce local to global scale pollution by ultrafine particles. It will improve air quality and also improve terrestrial ecotoxicity. We have scientific evidence on reduced health risk with lower particle number concentrations, even when we assess them by particle mass, in a few intervention studies, which I will very briefly touch upon. For the breakware filter, we also can make a reduction from local to global scale by the different particle mass measurements. We can improve air quality, improve aquatic and terrestrial ecotoxicity, and there's a very strong epidemiological evidence on reduced health risk at lower particle mass concentrations. And finally, for the filter squares, we have a possibility to reduce challenge microenvironments by pollution, either can be both, considering ultrafine particles, but also particle mass concentrations and heavy metals. So, for example, this will be discussed, I think, in the area under the use in metro stations. So here we can improve the air quality and reduce local peak concentrations to particle exposures. But one thing that's very clear is that we need to have a better understanding on the impact of ultrafine particles and mass concentrations. This is just for illustration. Some years ago, we did some analysis in Copenhagen on the ambient air pollution in streets. The red bars, we show the annual variation due to traffic. And in the lower end, you see actually the background air pollution of the city. And you see the air pollution variation inside an apartment close to this street where we measured. And you can see that you have very high variations in the street and smaller, but still variations in the apartment close to the street. This was an uninhabited apartment, so low levels of human influence on the air pollution. Below, we see the mass concentration variation. We see the same fluctuations, but to a much lesser extent. And we relate, of course, these mass concentrations to the air pollution. So they are indicators of what is happening. But we know from toxicology that there's a very clear link between very small particles and their effects. We can inhale them, they can be deposited in the deep lung, and what is specific for these very small particles is that they can translocate, and we get maybe some additional effects, neurotoxicity, for example, that can be due to ambient air pollution with ultrafine particles. But mechanistically, they work more or less in the same way as also coarser particles, and that's probably why we see some of the same effects for PM and the mechanistic understanding on what would happen to ultrafine particle exposure. Interestingly, as discussed, there's not very much hard evidence on the ultrafine particles and effects, but there has been some intervention studies where they have tried to study the effect of reduced traffic and putting in different interventions, and we see something more or less on the same scale regarding the different studies and the different size fractions investigated. So there is an indication from literature already that the reduction of what we know is a source of the ultrafine particles to a large degree can actually also be shown with PM values in very well-controlled studies. So we do have an indicator that we will apply also in our further assessments. So the three retrofit solutions are promising methods to reduce particulate air pollution from microenvironments to city scale and beyond. We have three solutions that can improve to sustainability, addressing up to 10 sustainable development goals and associated economic benefits, and this assessment is in progress currently. Also, we have a very clear link between particle mass concentrations, exposure, and human health effects with premature deaths and hospitalizations. And there is a challenge in how we can describe this effect on the particle numbers. We are working on this, and hopefully we can get a clear message in a few months from now where we end the project. So thank you very much for your attention.
And I thank you for rushing through. No, really, really thank you, Cope, because you now rush through something I think that is really relevant for the project. And so I ask to the audience whether you are already very hungry or whether you could give us 10 more minutes, because I really would like to bring all three speakers up to the bar. Thank you very much. And again, we have got probably on screen for any question that might come in online. And you are also welcome to ask some questions. What I love about Cole, what you said, was the work in progress, because it's ongoing, and it's ongoing also moving. And I think every day comes something new. And I personally, I really miss that I didn't bring my circle of the SDGs. It would have been very well here. When you say the SDGs, you identified various that could be relevant. Are you already in a position to say this is the most relevant, or are you still evaluating?
The most, sorry?
The most relevant.
I think the four that we picked out are the ones where we probably have a clear message, most straightforward message regarding human health, sustainable cities, and the environmental impacts. Depending a little bit on the different solutions, they will have different impacts there. But probably the one that is the most heavyweight regarding really driving implementation, I would say, is probably human health, because that's where we have most studies and we have most clear economic, you can say, cost analysis related to these effects.
I'm glad you picked that one up, because I would like to link it with family. I mean, the health system and the aging people, and who is looking after the elderly people. How are we going to finance it? Is it going to be from the state, or do we have to look after the families ourselves? So what interest, because we spoke about what interest might society have into this solution? Mm-hmm. Yeah. And also to get the governance into it. And when you talk about money, you have got various aspects. When we talk about environment, just to look at you, it's kind of raising awareness about the environment. What would be your take on it? How can you bring it more, make it more simple, as it was kind of said? What would you do?
Yeah, I think the issue with the environmental analysis is that it's a bit intangible, and as it was said, maybe you get a number that doesn't mean much to you. So I think our next step is going to be to translate all of these environmental impacts on the ecosystems to the number of species that this affects. So in a sense, you can actually see what the impact on plants and on animals on land and on water the solutions would have. Yeah. Yeah.
Sorry. We cannot listen. Would you guess? Would you guess that there are different results in different countries for this reason? We need to look into the countries, or might there also common denominators or common factors where you can say, due probably climate situation, yeah, that might have an impact where you say this works in this area in Portugal, but it might also be applicable in this area in Italy. Just a guess, curious.
There are, for the environmental LCA, you can actually classify it per regions. So indeed, the data is in such a way that you can say what the impact would be if you have it in Germany or if you have it in Mexico, for example. Yeah.
That's
Not for everything.
That's a great one because it allows me to go back to COLD. It's the SDG goal of the collaboration because from my perspective, we don't have time. So how can we speed up the learning for the communities from the results to get it down? Any comment from your side?
How we can speed up the process? Well, I think that we see it as a little bit of a challenge to move fast because there is a political process that is required. I mean, you cannot just require an environmental zone. As far as understood from our local satellite meeting we had last week with policymakers, that you cannot just in a city say that we want you to have a tailpipe filter and a breakware filter. You need to go through a political process, a European hearing process also for implementing those. So I think it's important. One green mechanism could be that cities come together and say, we want to reach the WHO targets on ambient air pollution, and what are the quick fix instruments that we could apply. And here we have indeed quick fix instruments available. So instead of spending a lot of time discussing and running through different actions and so on, and not waiting for the exchange of or the change of cars into electrical or hydrogen powered mobility, then there are these solutions that can help us reach at least in part these goals on a very short term.
Thank you for that one, Kels. It's the collaboration and the communication and the having examples and cities that support, which I'm very grateful for. And I thank you three really for your contribution. Thank you very much. And that's great.
We have a question from the audience. If
Yeah.
Did the LCA consider the climate benefits of PM tailpipe control? PM is predominantly black carbon, which has a very high GWP, global warming potential.
Yes, the LCA did consider the climate benefits in terms of black carbon and several other comments that are released. And because it is a life cycle assessment, then we also considered everything that was released into the atmosphere during the manufacturing phase, and then we assumed a correct implementation of the end of life phase. So yeah, indeed, it was considered. And I just want to add that it is all compared to a baseline, and then you have to think what the baseline would look like. Would it be a vehicle without any filter at all, or would it be a new vehicle with the OEM filter installed? And indeed, that is one of the benefits of having a retrofit filter, is that you do not require to have a whole new vehicle to have it. But coming back to your question, yes, it was considered.
And I thank the audience for online still sending questions in, and that's great. One more?
Yes, there is another one. What lessons did AeroSolfd learn when performing LCA and overall sustainability assessment for its retrofit solutions that could be helpful for other cities or projects?
Do you want to take it, or shall I take it?
You can start.
Okay. I think something crucial for cities is that right now, whenever you have a new technology that will help the society, the main idea is to discard what you have and to go on to the next new technology. And the LCA is a way that can show you how that is not always the case. And perhaps if you have a solution that can work with the systems that you have today, such as retrofitting something that you have today, may be actually more beneficial than overhauling and having a new one installed. But then again, that's why it's good to look from the manufacturing till the end of life to see what the difference would be between having the new technologies installed from scratch or improving what you have today. So I think that's something that cities should be able to look into.
I'm interested in Kelt's OSA perspective.
Yeah, I said we're still work in progress, so it's maybe too early to say exactly how we can help. But I think that the solutions or the results are quite generic. I mean, every city has their traffic air pollution issues. There are different solutions that might be more beneficial in various cities. We know that transition into electrical mobility is happening at different paces across Europe. There might be certain areas where the breakware solutions would be more, you can say, beneficial on a city level. But my recommendation would be to actually implement all approaches to the best level possible, because first of all, you have pollutants from all sources. And also that pollution is actually not only a local scale, it is a global scale problem. So we should make a joint effort towards to implement these solutions.
It's a wonderful sentence how to finish this session. Thank you very much. And an invitation for anyone in the room, if in the next month, years, you take public transports and are sitting in a bus and it breaks and it stops, think about AeroSolfd. That's my invitation.
Thank you very much, Ute, for moderating. Thank you very much to the panel. We now have a break here, a lunch break. We have a break online. Not a break in the sense that we stop. There will be some videos, some movies showing, so you can keep the streaming on connected and look at that while you have lunch at home, at the office, or somewhere else. And we come back here at 1 p.m., 1300 Central European Summertime, and we will then look into the results of the solutions and the technical solutions. Please join us again and have a good break.
Particles emitted from petrol engines. In the last 2 years, particle filters have finally been developed for petrol engines, which, thanks to their innovative pore structure, eliminate more than 99% of even smaller particles right from the start. Retrofitting petrol vehicles with such particle filters is even easier than with diesel engines, because the exhaust gas temperatures are higher and much oxygen is available for burning the soot during load changes to periodically regenerate the filter. Within the Horizon framework, the European Union has commissioned the Swiss Vert Association to prove that retrofitting can be carried out in any vehicle workshop and that safe operation is guaranteed. The AeroSolfd project operates a fleet of 50 vehicles that are typically used in city centers in Germany, Switzerland, and Israel. The future individual costs will be less than 10% of the commercial value of the vehicle to be retrofitted. This video is intended to show how the retrofitting of the particle filters for this test fleet is carried out.
Indeed, worldwide, there are many more petrol than diesel engines. Since the 1980s, these have been equipped with the so-called three-way catalytic converter, which perfectly eliminates gaseous pollutants, but is permeable to nanoparticles. Since conventional diesel particle filters are not suitable for cleaning petrol exhaust gases, a new technology had to be developed, with very fine porosity, to clean petrol exhaust gases almost 100% from solid air contaminants. This comes now into the market for series automotive applications. But what about retrofitting the many old petrol vehicles? And that's what this project is all about, that we can also retrofit existing vehicles with particle filters. For installation in the vehicle, we have this customized kit with the appropriate clamp, where the sensitive, brittle ceramic particle filter is covered by a fiber mat and pressed into a chrome steel housing, which protects it against vibrations and the environment against radiated heat. From the engine, the exhaust gases come through the three-way catalytic converter and then flow through the particle filter towards the silencer. And here, for our testing application, we also have various sensors. Firstly, the exhaust gas temperature, here the surface temperature of the particulate filter, and finally here the differential pressure connections. In this Peugeot 3008, which we've just picked up from the customer for retrofitting the particle filter system, we're performing acceptance tests according to Swiss regulations.
The noise emission is measured, electronic onboard diagnostics are read out, and an exhaust gas test is carried out to record the gaseous pollutants and the concentration of nanoparticles.
If the checks are successful, the particle filter can be installed. To monitor the behavior of the filter system during the 6 months of test operation, we have an ECU to record the data, an ECU here to transmit the data,
which are then available in a cloud so that we can monitor the system's operating behavior at any time. We can now start the remodeling. First, the existing system is opened at the separation points. Only a few screws need to be loosened to remove the existing exhaust system, a job similar to replacing a silencer. The customized replacement system with a filter is then installed in the same place using the plug-in connections and attached to the underbody in the same way as the original system. This may require 30 to 60 minutes and completes the actual retrofit.
I hope you had a good lunch break online and you could see some of the pictures and movies that were generated or that were taken during events during the AeroSolfd meeting. We are now at 1 p.m. here in Barcelona. My name is Martin Lehmann. I'm with Mann & Hummel Filtration Company, and I'm here as the coordinator of the AeroSolfd project, guiding you through the rest of the day. We will have the next session that will be on the results and the technical solutions. We are ready to retrofit, you will see. We have done demonstrations on site. We have a technical presentation now by experts, but before we go there, I would quickly get you back on page to that we have a common understanding what that project is and to give you some idea what AeroSolfd means. AeroSolfd means that we have aiming for cleaner urban aerosols, so it's air and particles, and we want to do that as a fast track, something that you can immediately implement and that can have an effect within the next years and not also on the long term, but you don't need to wait. You can already take some action as the results of the AeroSolfd projects are market-ready solutions, and we have that for tailpipe, brake systems, and semi-closed environments like metro stations. And these are filtration devices, and how they work and how they are designed, you will learn in this session with the 3 presentations, looking at a tailpipe particle filter, a brake dust particle filter, as well as a filter for metro stations. The project, to summarize it, as you might be joining just after lunch here at the break, or you might be just interested in the technical presentations. It's 17 partners working on that in 9 countries, addressing a call of the Horizon Europe Pillar 2 in 2021. It's funded by the EU and also funded by the Swiss with 2.2 million and in total 8.2 million budget. The companies, as in innovation actions, are contributing with 1 million. We have put the agenda together, and this morning we had started with the why. Air matters, what the new air directive of the EU is, that it's important to come to lower values, that we, the citizens, are looking into better air, and that there is also want some action, that there are solutions ready to do. We have looked into the impact, what can be assessed from sustainability point, what can be the time and the life saved, what can be the effect for a city, how does it overall work with the LCA. It's ongoing work, so these were preliminary results. Stay tuned and follow us on LinkedIn and follow us on the website. You will get the results shortly because the project is extended until end of August, so look at the deliverables, they will come. What comes now is the technical part, And you can see here on the right the partners that have contributed to it. So on the top line, we have the manufacturers, the companies who produce the filters, members of the Word Association, ZF, Mann & Hummel. Then we have companies who are in the assessment, measurement, like Link as a company doing the brake emissions measurement. Then we have our partners who did the demonstration, who were allowing us to install the filters, Metro Lisboa, or who were contributing by getting the way how buses drive in a city with LPP, Awasa, and Cornero Bus. And then the institute, the research institutes, who looked into the data and getting meaningful results out of that with IDAEA from Barcelona, Cardiff, the city of Valladolid supported, and this Sofia Development, also a strong partner in this project, to work together and provide the technical demonstration. So with that, I would like to, there's here some logistics, some water. Please go ahead and provide water. We will get real data now. We will look into what we can do and how these solutions work. And we will start with a tailpipe. So it's my pleasure to welcome Lars Larsen from the Word Association, talking about reducing tailpipe emissions of gasoline vehicles, looking into the solution, the technical part, and also the demonstration. So with that, I'm just moderating this one. I hand over to Lars, and please, to the technique, provide the slides, technical slides for Lars to present.
We've been working with this project now for almost 3 years, and I think for me it becomes increasingly difficult to keep myself short in the presentations because there is so much knowledge created and so many interesting facts and so many interesting conclusions drawn that sometimes it's difficult to choose which of these conclusions and statements should you actually keep in the presentation. And sometimes I wish I was a real president. I'm a president of a small organization in Switzerland, but if I was the big president over there, I would just start the presentation by saying, particles are bad, very bad. And then everybody would listen and understand. And this is basically the message of the whole thing, is that we are living in a world where particle emission has always been related to particle mass, and in this case has shown that particle emissions from petrol engines or gasoline engines is absolutely minuscule. And my apologies for the formatting of this presentation to be a little bit out of line, because the basic purpose of this slide was to illustrate two pictures, one with a hazy horizon of Beijing and another one with a very crystal clear horizon. And actually, there was a contradiction in the two pictures, in the sense that on the hazy one, we had a very, very high particle mass. And on the crystal clear one, we had very low particle mass, but extremely high particle number concentration. Anyway, I'll just move, and just based on the conclusion that there is an apparent disconnect between particle mass and particle number when we talk particle emissions from gasoline engines. We drew the conclusion earlier today that the clear statement to start out with this presentation is that particles are bad, but the smaller they get, the worse they get, because they can penetrate into the human body, carrying other toxic substances which may have severe consequences for health and life quality, and also for the mortality. And a large proportion of the particles that we actually measure in the small range is due to combustion of gasoline in gasoline engines. Just to put things in perspective, we have for many, many years a very good emission control of gasoline. Gasoline is dealt with by a three-way catalyst, and the three-way catalyst does three things. That's why it's called the three-way catalyst. It oxidizes unburned hydrocarbons, it converts CO to CO2, and it reduces nitrogen oxides and dioxides into nitrogen and water vapor. The only thing that it doesn't do is it eliminates particles, because particles are just freely emitted into the exhaust, and that is what we're dealing with here. We are adding the three-way catalyst with a physical unit called a gasoline particle filter, which has a very high filtration efficiency. And now I'm ahead of myself. The GPF is, in contrary to the DPF, a filter that you fit on gasoline-powered engines. The difference between the DPF and the GPF, sorry, am I doing that? No. Is that the pore structure of GPF is slightly optimized compared to the DPF, because we are dealing with particle emission in the range of 10 nanometers up to 100 nanometers, where the diesel engine, the particle number distribution is slightly higher. So we require a pore structure that is allowing for much smaller particles than for diesel, without compromising the pressure loss of the system too much. Just to highlight the project, we have tested and validated GPF. We have shown that we have more than 95% filtration efficiency. We have completed a field test to ensure that this is, microphone, sorry. I was just feeling that my English wasn't good enough. Anyway, we also tested this in the field to make sure that we were not creating a paper beast of something that only works in the lab. But basically, it's also quite applicable into the real world. And then finally, we have also tested, and that is following VERT guidelines since 20 years, that we will ensure that any after-treatment technology that we apply to mitigate particle emission is not associated with some other weird features of secondary emissions generation that will cause as much harm as good for removing the particles. The objectives in the program is 5 objectives, and that relates to 6 deliverables. We had to find the right vehicles to test. We had to do in-depth emissions testing with 4 of these vehicles. We measured toxic secondary emissions along the particle filtration efficiency in the lab. And we did a 6-month field trial, and the goal was 50 vehicles, 20 in Switzerland, 20 in Germany, and 10 in Israel. That turned out to be 2 in Israel, because they have slightly more serious issues to deal with down there than Retrofit. And then it ended up being 20 vehicles in Switzerland, 17 in Germany, and 3 in Denmark. And then what we did to benchmark it all with reality, and that has become a quite important point, we made an arrangement with the Swiss Touring Association, and along with their annual MOT, we picked 1,000 vehicles, and 1,017 to be precise, and we measured the particle number emissions from these randomly selected vehicles, which ranges from Euro 0 all the way up to Euro 6, and measured how do they actually behave in the real world in relation to in-use compliance. So the methodology of the whole program is that we do lab testing, real driving condition, exhaust gas and particle analysis, fleet testing, baseline testing, application testing, and we also spend quite a bit of time analyzing, is this worth the effort in terms of cost versus the benefit? But as we already discussed this morning, there is a bridge to be built between particle mass PM2.5 and particle number in terms of epidemiological studies, which we were training yesterday, because that's one of the words that I face severe difficulties saying in the English language. Anyway, that still misses for particle number, but there is a lot of toxicological studies and a lot of studies in general that actually supports the fact that small particles are bad and very bad for health. And then finally, we also had the overall goal of providing a TRL8 product. And I mentioned that this morning. Don't come up with something that is too complex and too far away from commercialization. You need to build a system that is based on existing components, working practices, and components, because we would like you to see something that is actually commercial after ending the project. And the most evident sign of something that can be commercialized is that you have a type approval of the product that you provide. Results in the lab, we did chassis dyno tests on the 4 vehicles. We measured with FTIR, we did all sorts of analysis. We ran the world-harmonized testing cycle in cold part and in warm part. We did real driving emissions with PIMS. And basically the filtration efficiency was in the high end of 95 to 99 point ever on the particle number. And if you compare that to particle mass, I would claim, because I only have 20 minutes, so questions are limited, that if you have 95% particle number filtration efficiency, you will have that for particle mass as well. But it really doesn't matter here because the particle mass contribution from a petrol engine is minuscule compared to a diesel engine and many other sources of emission control. So basically, we have demonstrated in the lab, and Mr. Lehmann showed that graph also, that particle number as the OEM version, so that means a vehicle without a GPF compared to the same type of vehicle with a GPF retrofitted, we have one order of magnitude of reduction in particle number emissions, and we have no increase in NOx. Part of the AeroSolvd program was actually also to reduce NOx, but very early in the program we decided that with the 3-way catalyst that I mentioned in the beginning, we have a very, very efficient NOx reduction if the catalyst works. There is a lot of issues with in-use compliance also for 3-way catalyst, and there is a lot of dodgy products out there supplied by companies who can make a quick buck by selling 3-way catalyst without the necessary precious metal coating, and therefore the performance of the catalyst may not be the best. So basically, just to ensure that the catalyst is in working order is a NOx reduction contribution to the program that should be regarded adequate. And if you say you have an average efficiency of NOx reduction of 95%, it may not be worth the effort to chase the last 5%. So that was kind of the pragmatic approach to this. As I said, we did it in the lab, and that's been done in Switzerland. And the same vehicles has been running on the street. And before I get to that, just on the curve to the right for you, is that the difference between a diesel particle filter and a gasoline particle filter, due to the nature and structure and design and material composition of the gasoline particle filter, which I walk away from the microphone, it looks like this. This is a cordierite-based wall-flow structure with 300 cells per square inch, with a porosity of 40–45% and an average pore size of 3 to 5 micron. This is the thing that does the job, and this is the thing that is also applied for new vehicles. This filter have a filtration efficiency that is almost 100% in the beginning of the installation, where often you see a diesel particle filter increase efficiency over time as you follow the sod loading. So the more sod loading, the more the filtration efficiency reach around 100%. So results in real. The real driving emissions is always a discussion, because when you decide the test method or the test cycle, the transient or the steady state or whatever, it's always a discussion whether that is representative in the real world. And I think a lot of very well-skilled and educated people have spent years and millions of hours of discussing how you should design the test cycle so it also reflects reality. I don't think we've ever reached the truth, but we will get a reasonable proxy for estimating that. And also development in measuring equipment has also brought us to a situation where we can actually bring the measuring equipment in the back trunk of the car while we are driving. And that is real driving emission, and that is what's called PEMS, which is portable emission measuring systems. In the old days, that equipment would have taken another truck running behind, and these days the equipment is so condensed that you can actually keep it in the car, which was one of the reasons why we had to take the Fiat 500 out of the equation and replace it with the Fiat 500X, because the normal Fiat 500 was so small that not even the PEMS measuring equipment could be in the car. So this is actually showing the results. And with the GPF and without the GPF, we have very high filtration efficiencies, but also very importantly, the CO2 emissions, which is the proxy for the fuel consumption, has not been compromised. So we don't have any measurable differences in the lab nor in real driving conditions where we would see an increase in fuel consumption. And that is very important because increased fuel consumption will give you more CO2 emissions, and that will be a bad message to send, both to the wallet of the owner as well as the politicians. In the middle, we have an interesting thing, and that is the first study we did on the 1,000 vehicles that we took out of reality. And these vehicles were measured, and they have a group of these 6 classes, 7, Euro 0 to Euro 6. And then what we see here, and that is one of the very interesting and fine conclusions of the project, is that very few vehicles in the fleets, in the real life, is actually polluting more than they should, as which they were approved for. Their homologation values are exceeded, in the sense that we can create a rule of thumb that says that less than 10% of the vehicles in the street is representing over 90% of the pollution, because they're out of order. The three-way catalyst doesn't work, the filter doesn't work, the injection system is out of order, or the engine has just been worn so much down that you have pollution beyond imagination. This I will get back to. So what do? We came up with the solution. I will walk away from the microphone again. And I have 4 minutes and 46 seconds back. This is the final thing. I can hold it here. Here we are. This is the assembly. This is the filter that's inside it. This is, from a weight perspective, very light because it's very porous, it's very efficient, it's not very expensive, and it's an off-the-shelf product because it's currently manufactured in Germany in hundreds of thousands, because that is what you currently install on new gasoline-powered vehicles. It's been integrated. So the biggest challenge now is that we have the filter, it works, no secondary emissions, no pressure loss that will result in any increases in fuel consumption, and the thing is relatively inexpensive to manufacture. The biggest challenge is to apply this to the vehicles on the street. So therefore we have done a design work. So based on the optimal modular approach, we should be able to cover a very, very large proportion of the fleet without compromising or changing too much in the exhaust system, based on the starting point that the three-way catalyst needs to stay in its original position, so we don't change that. And then you cut out a piece of pipe before the silencer that comes, and you fit the filter assembly in between. It is not that easy because space is limited on the vehicles, and sometimes we need to replace the silencer with an assembly. Sometimes we need to make a combination product. Sometimes it's completely impossible. But nevertheless, I think with reasonable application development effort, we will be able to cover 80% of the vehicles on the street today. Finally, we did a 6 months field trial. 42 vehicles. We have had surveillance or exhaust monitoring on all 42 vehicles, online reporting on back pressure, exhaust temperature, and surface temperature. It was measured with a frequency of 60 hertz, and any alarms, if back pressure was exceeding the thresholds, if the surface temperature was exceeding the thresholds, or if we saw any odd behavior of the exhaust temperature, we would have an alarm and we could warn the operator before they knew it themselves. So therefore, we have a pretty good and solid database of performance. And we've had 3 alarms, and all 3 alarms for 42 vehicles for more than 6 months was related to system errors. Finally, we took one filter out, which had actually been doing most of the time, over 12,000 kilometers, and we did post-mortem on the substrate itself. And I actually saw one myself after, and it was absolutely amazing how clean and nice it looks which actually says something about that what we remove, we cannot see. And this is the whole dilemma of all this, that we are dealing with not visible pollution, but invisible pollution. But most importantly is that the ash accumulation and the filter's ability to regenerate is existing during the operation. In the old days with diesel particle filters, the biggest challenge is that you have a lot of mass and very low temperature. And if you need to clean the filter, it requires regeneration to keep the back pressure at constant levels, you apply a catalytic wash coat to reduce the temperature under which accumulated soot is oxidized. And it's always a nightmare. A lot of mass, an inadequate temperature, and a lot of precious metals. In this dream scenario, we have a lot of temperature and also sometimes oxygen during the transients of the normal operation, and extremely little mass, but very high number. We are able to keep the back pressure constant over time and not compromise the engine manufacturer's recommended thresholds of back pressure at any time. So that is a dream scenario. We should have started putting filters on gasoline instead of diesel, because this is much easier. Good results I have already mentioned, but I think it's worth repeating that we have come up with an application that can be installed in less than an hour, and I joined such an installation process myself. It can be done at a cost of less than €1,000. So it's not a $1 million type of super technical complex thing that we have come up with. It is TRL8. And fortunately, we were not forced down the road of applying a catalytic wash coat, because that will put another pressure on rare metals. It will put pressure on the cost structure of the system. And then finally, I was happy to announce that after months of waiting, that we received a Teiltypgenehmigung from the German KBA based on the test reports made from TÜV. And this actually is the evidence that we have come up with the TRL8 product, which is the 6th deliverable and overall objective of the AeroSolvd program related to Work Package 1. Impacts, I think we can only repeat what's already been said. And then Dr. Meyer, who is chairing the scientific committee of the World Association, has tried to do a correlation based on the studies already done with the CVD value compared to particle number concentration compared to PM2.5. So the work has started. I think there is a lot more things to do. And then finally, reducing black carbon emissions also have an impact on global warming, in the sense that the albedo effects and so on is actually also a good contribution. And therefore, a lot of correlation issues, cost-benefit analysis has been made to justify that what we do here can be done at less than 10% vehicle. So my last slide, I'm over. I started with a slide of the picture of very old-fashioned after treatment, very large particles to the left. And what we do to the right is the ultimate solution, filtrating particles all the way down below 23 nanometers. And on the left side, we're not talking nanometers, we are talking centimeters. So basically that was the end of my speech, and basically reminding everybody that we have combustion technology on the roads for many years to come, whether we like it or not. Was that reasonable?
Thank you, Lars. That was very great. On time and good content, as always. For questions, we will do that later in a joint round. We will, on the web, yes, the Slido, you can already put in your questions. If you have questions in the room, great. Write them down or remember them later for the Q&A session that will start. It's now my pleasure to walk forward with a brake dust particle filter, reducing brake dust emissions of urban buses. The presentation will be by Christoph Asbach and Hartmut Niemann. Christoph, I know since many years or decades already, 2004, and he is always great in aerosols and particle technology, so great that you are here. And Hartmut, he did his PhD on very specific measurements on brake emissions, a nice study on that one, and I let the floor to the experts now. Please go on stage and use the mic.
Oh, thank you very much, Martin, for the nice introduction. I'm happy to answer now in the next 20 minutes together with Christoph the question, how much can we reduce particle mass emissions from brakes for city buses with the Retrofit brake dust particle filter? So let's grab the pointer here. Let's start with the basic function of the brake. Why does a brake emit and how does it work in general? So a passenger car disc brake works by pushing a pad on a disc, generating friction force, and this friction process generates particles that are emitted into the environment. A very nice thing about a friction brake usually is nowadays that it's ventilated. So it's cooling itself by ventilation, and this ventilation can be used to transport the particles in a direction where we would like them to have, and this is inside the brake dust particle filter. So you can see those ventilated. Oh, it's difficult to point here to the right direction. You can see here the slots for the inner ventilation around the circumference of the brake disc. And with that macroscopic view of the brake, I will give now the floor to Christoph, who will explain you how the particles are formatted exactly on the more microscopic view.
Okay, thanks Hartmut for setting the stage. And yeah, Hartmut already introduced that in a friction brake, we have a disc and we have brake pads, and the brake pads are pushed onto the disc to slow down the rotational speed of the disc. And it's actually by friction. And if there's friction involved, it's quite apparent that friction generates particles by abrasion. So what we see here is the promised, what we don't see is the laser pointer, but what we do see is there it is, not here. Okay, it's okay. So we can see this is a part of. You have to look on the laptop. Now it's also here. Is it there also? Okay. So, so there's this is the brake pad. We have the disc here, and so if they move relative to each other, we have friction involved, and then it's apparent that we do have the generation of particles by abrasion. An abrasion, mechanically generated particle. As an aerosol scientist, I know mechanically generated particles are large, and I ask you to be a bit patient. I will tell you what, for an aerosol scientist, large means. But of course, if there's friction involved, it's also obvious that it gets warm. And when it gets warm, we add an additional particle generation process by thermal particle generation. Because what now happens is once the brake gets warm, we have an evaporation of pad material, the binders especially. And so we have an evaporation, we have a vapor phase, and then it's transported away from the filter, from the brake. It cools down, thereby it supersaturates, and then we have new particle formation by nucleation. So the molecules start to stick together and form new particles. And these are very small. And again, I'll tell you what very small means in a bit. And in very high numbers. And so looking at the size distribution of these particles, so that's what we see here. Oh, and I guess here. So we see two different graphs. With size distributions, actually from two different measurement devices, so it's separated in two different graphs. So on the y-axis, we see on a logarithmic scale the number of particles emitted per braking event, and on the x-axis is the particle size. And each of the individual lines is a different type of braking action with different energy input into the brake. So the highest one, the red ones, is actually for slowing down the brake for the car from 175 to 100 kilometers per hour with a deceleration of 5 meters per second square. And then the lowest one is actually to come to a full stop from 40 kilometers per hour to 0 down. And what we can clearly see is that no matter what type of braking energy is applied, we always see this peak at a couple hundred nanometers to a few micrometers. So that's what we consider large. A few hundred nanometers to a few micrometers. So these are mechanically generated particles. And in addition, we see, and there is a variation depending on the energy input, but it's not very strong. But then at the lower end of the size distribution, we see small particles. And small in this sense means around 10 nanometers, so much, much smaller. But we also see there is a much larger variation of these. So from actually at the lowest energy input, we don't see the formation of these particles at all because it's too cold. But then at higher temperatures, we see that they start to be generated. And the difference, remember, it's a logarithmic scale from here to here, is actually a factor of 1,000. And if we look at the number of particles emitted per breaking event as a function of the temperature, we can clearly see that as when the break is relatively cold, we don't see a lot of particles being generated, but then there's a critical temperature, and you can find that in many studies, it's around 150 to 170 degrees, and then it starts to increase significantly because that's the onset of the thermal particle formation, so we see a lot of very small particles being generated. Now, we know that these particles are being generated by the break disks, but the question is, how relevant are they? And I know this is a very busy graph and it's a bit difficult to follow, but no worries, I'll walk you through. So what we see here is actually the toxicological effect of break dust. In this case, it's for systemic inflammation, and the different graphs just indicate different endpoints, or different effects that you may see. And on the y-axis, we see different types of materials. It includes break dust, but it includes also others for comparison, including tire wear, poultry farm particles, different types of stokes, etc. But what's important as a take-home message here is the y-axis is actually the dose that would need to be deposited in the lung, so the amount of particles that needs to be deposited in the lung to cause a toxicological effect. That said, it's obvious that the further left it is, the worse it is from a toxicological point of view, because that means already at a low dose you see effects starting to happen, whereas the further right they are, the less toxic these materials are. And I mentioned is break dust included. I marked them here with a red box around it, and it's actually 4 different brake pad materials that have been tested. Again, I don't really want to go into detail, but what we can clearly see is that some of the brake dust particles that were tested here end up on the very left end. That means with a high toxicological potential. That means brake wear is toxicologically very relevant. It depends on various factors, including the pad composition, and we see that some of these compositions even have the highest effects that we see here. And that means if we can reduce the brake wear emissions, we lower the burden on the general population. And now you may say, okay, but we see that there are particles, but how much is it? In fact, we see that it's ever increasing for the past couple of decades. And there are different reasons. One is increasing traffic. And we'll see on the next slide, it's also the increasing vehicle weight that plays a role. So what is shown here is actually a prediction for the UK, and you can for all non-exhaust emissions, and we can see that all of them are predicted to increase over the years. And if we just look at the brake wear down here, of course, it depends on the amount of electrification in the fleet and the use of regenerative braking, but it's still predicted that it will increase or just slightly decrease over time. And having said that, it depends on the vehicle mass, and everything that I showed so far was mainly for passenger cars, but we know that the brakes are very comparable to the buses. But so how can we now transfer that knowledge to city buses? In fact, this is a graph also again for passenger cars, but what we can clearly see, it's actually the amount of particulate matter emitted per kilometer for tire wear, brake wear, and road wear. And if we just focus on brake wear, we see that it increases with the size of the vehicle. So it's just categorized into small, medium, and large. And they came to the conclusion that it actually scales pretty much linearly with the vehicle weight. And that means for city buses, coming back to the last couple of slides, the good thing when it comes to emissions, brake dust emissions from buses, is they have a rather low speed because they're only, for city buses, they only drive in urban areas where they cannot and are not allowed to drive faster. But the bad thing is, of course, the buses are heavy. That means they have higher emissions because the vehicle mass directly plays a role. And of course, they have frequent stops because that's the job of the bus, to stop at the bus stops and collect new people and release the passengers there.
And we learned in the morning that we need to do something to reduce the air pollution levels in general. And one thing is legislation. And we already discussed about Euro 7, which is for the first time, it includes also limit values for brake dust particles. But if you look at this table from the Euro 7 regulations for the brake dust limit values, we see there's currently only a single value, and that's 7 milligrams per kilometer for PM10 for M1 and N1 vehicles. That's actually passenger cars and small cargo vehicles, and it will be reduced to 3 milligrams per kilometer in 2035. All the others, including those for buses, which are M2 and M3 vehicles, are still left blank, but it doesn't mean that there will not come this. This is currently still under discussion, so there will be a limit value for these as well. So the idea we had in this project is to develop a brake dust filter which can reduce, it cannot avoid particle generation, but it can reduce the emission of these particles. And there are two different concepts. It's either a passive filter, which can be installed and used in a way that Hartmut introduced. So you make use of the ventilation air that is passing through the disc and pass this air through the filter and thereby capture the particles. The good thing is this is easily possible to retrofit. And then there are also active solutions. I think in the sister project Vera, they follow such an approach, which can, of course, be more efficient because you withdraw the air directly, actively. But, of course, it's much more difficult to retrofit. Both solutions already exist for passenger cars. And here in the project, we did the development of the passive filter for city buses, in fact. And just to let you know that it really exists. So here's, now it's actually, this is a digital image of it, and that's why you can easily take it apart without any tools, just with a click of a button, but it does exist. So this is what it looks like in reality. That's the prototype with the caliper down here and the filter up here, where you can also see the filter material, the pleated filter material. And this is how it looks like when it's installed. And when I say installed, it's actually not, you will notice, on a vehicle, but it's on a test rig. Don't be surprised about all these cables and wires. Those were only used for the experiments to measure the temperatures, etc. And by the way, experiments, that's for me the key word that I should hand over back to Hartmut to explain a bit more about experiments and the results.
Yeah, so far we know brakes are emitting particles. We know which particles are emitted by a brake, and we know they have an impact, a toxicological impact. And now the next question is, how can we measure them? How can we measure brake particles from commercial vehicles robustly? So we already know from passenger cars, the most robust way to measure brake wear particles is in the lab with a dynamometer. Therefore, we have a specific driving cycle which represents the driving conditions that a normal passenger car has in average. For commercial vehicles, and especially for city buses in special cities like our partner cities, we do not have this information. What is a representative driving condition? And for that purposes, we started in the project to collect data from real driving in Valladolid, in Ancona, and also in Ljubljana to understand what are those representative driving conditions. Here on this slide, you can see a picture of a fully equipped bus in Valladolid, which had measurement devices to measure the speed profiles, temperatures of the brake discs, and also the wear of the brake pads were measured. And with all that data from here in Valladolid, for example, it was 1 week measurement campaign. We started the task and summarized this 1 week measurement data to a representative driving cycle that is just half an hour on our dynamometer. Therefore, we used a so-called short trip methodology. This methodology was also used in other projects, like or in the development of the WLTP brake, the WLTP exhaust, and other driving cycles that were used in in other European projects. And on the left side here, you can see the time series of the velocity of this new generated driving cycle, which is approximately here 20 minutes of driving time. And now to make sure that this driving cycle represents the real-time data, we looked at one value, which is the cumulative distribution of velocity and acceleration and which can be shown here in a nice, colorful picture on the right side of the slide. So this picture contains all the information of the statistical properties of the driving cycles. And now when we look at the same picture for the overall database, which means the 1 week measurement, we see this is very similar already. But what we did, we compared like the both, or the information from both pictures or both graphs in a way that we minimized the difference for different driving cycle candidates that we generated. So overall, we were generating 400 driving cycles just for Valladolid for one bus line, compared them to each other in a statistical way, and picked up the one that fitted the distribution in the best way. So with that you can also, if you look at this in 3D, it's all nice and colorful. But if you want to look at it in a more, in a better comparable way, you can transfer these graphs also into 2 dimensions, which you can see here on the left side for acceleration and on the right side for velocity. And you see the blue line, which is a database, the 1 week measurement data, and the orange dotted line, which is the cycle candidate, the newly generated one, are really line on line, which means they have a very, very good, perfect fit to the overall database. Now with that new cycle, we can go to our newly developed test tool. It's a commercial vehicle dynamometer, specially equipped with emission measurement devices for measuring brake particles, and also with an enclosure that makes it possible to collect all the particles that are emitted from the brake and transfer them to our particle measurement devices. So general overall, you can see here, this is the brake, which is emitting the particles. The big shiny enclosure here is the enclosure that encloses the brake and makes it possible to let an HEPA filtered air through the or over the brake and transports all the particles away from the brake to our measurement devices. And the measurement devices themselves, they can be found here after the sampling tunnel. And I will show you on the next slide another view where you can see them. So we have devices for measuring particle number. So those are the metrics that Lars were referring to in his presentation. But we have also devices for measuring particle mass. There you can see the 2 blue cards here on the right side, which are of especially interest for the brake dust particle filter, because we wanted to look at PM10 reduction of brake dust by this particle filter. And this is, we use those devices to measure those metrics. On that slide, you can see now the results from the newly generated driving cycle tested on our dynamometer. So you have a blue solid line here, which is the speed trace, approximately 20 minutes. Then a temperature profile, which we could compare against the temperature profile that were measured during our test in Valladolid, for example. And also the time series of the particle number emission concentration, which can be found here in orange above. So you see those, we transferred the real world driving to our test lab here. And now concluding with the results themselves, we conducted multiple test series to test the performance of the brake dust filter. And you can see here with the blue bars, the PM10 results without the retrofit solution, without the brake dust particle filter, where we end up at approximately 43 milligram per kilometer. And with the brake dust particle filter, we were able to reduce this emission factor down to 26.9 milligram per kilometer, which is an overall reduction of 38% PM10 for this application for a city bus in our tested cities. And this is a very promising result. And with that, I give the floor again to Christoph to present the outlook and the next steps.
Thanks, Hartmut. I'll try to be quick. The clock tells me I only have 30 seconds to wrap up, but all right. Well, I think we've shown you that the filter is now available. It's ready, it's tested, it works. It's available as a retrofit solution. That was the goal of the project. But of course, it can also be applied to new original equipment. And the good thing is it's quite flexible, so you can actually adapt it to pretty much any brake or future developments that are out there. We're thinking, I mean, this one here was specifically for city buses, but it can also be applied to other heavy-duty vehicles. And we found it to be, and we didn't go into detail, to be actually most efficient at rather lower velocities. That's why it's so good for urban areas. But keep in mind that urban areas are also the most polluted ones. So they're really most effective in places where where it's needed. And other vehicles that are only used in urban areas, or mostly used in urban areas, are, for example, garbage trucks. They have a similar profile, driving profile, although I would assume that maybe their velocities typically doesn't go that far up, but they make more frequent stops. So that's, again, something where the brake dust filter can be very efficient. And similarly to what Lars has presented for the for the gasoline exhaust filter, we also work together with KBA and TÜV to define the process to get a type approval for this filter. And the whole process has been approved by KBA, so the German Motor Traffic Authority. And so it will be possible also to get the type approval for the filter. So with that, I would like to summarize and conclude. So we've seen brake dust is indeed toxicologically relevant and therefore a very relevant, especially urban air pollutant. We see limit values are under development for city buses and other heavy-duty vehicles. So they will come, and we worked on a solution to push existing brakes towards these to low emissions and to meeting these new requirements. But of course, it's a solution that can be also applied to any vehicle, large heavy-duty vehicle. It has been proven, Hartmut has shown that, on a unique and tailored test rig for heavy-duty vehicles. We've shown that with this specific driving cycles for individual bus lines in different cities, the brake dust filter reduces the PM10 concentrations by 35 to 40%, and the commercialization is already in progress. So with that, I would like to thank the sponsors of this work, and I hope I also speak for you. We would like to thank you for your attention.
Thank you very much. Various interesting insights in how to get a brake dust cycle for a cycle for braking of a city and how the solution works. We are staying in the city. We are using another public transport. We are moving forward to a metro, and that's a different environment as it's a semi-closed environment. And we have two persons who are presenting that work. So it will be Teresa Moreno, whom has been already introduced, and it's my pleasure to introduce Guilherme Ricardo from Metropolitano Lisboa, who was involved in that project, and who will also present the view from the metro operator. The floor is yours,
okay.
And you will figure out who will talk when.
Thank you very much, Martin. So this is a shared presentation because we have been working together with lots of partners in this activity. It was quite intense, but we are going to go for it now. Right. First of all, I wanted to say that we are looking at things to improve the air we breathe, and most of the time we spend it in ambience indoor. And this is just to check if you are awake or not, because the figure is wrong. And it says that we spend, the percentage is wrong. We are indoor 80% of the time or 85% of our time. You see the cake is wrong. Okay, so if we spend so much time indoors, one part of these activities we do indoors is commuting. We all have to travel in our lives, in our working lives, to work. So how much time we are spending when we are traveling? It depends on how lucky you are and how close you live to your working place. But imagine like you are, for example, one day, one way trip is about half an hour, and then you have to go half an hour in the morning and half an hour coming back. That means that in a year, you will spend about 10 days breathing air in the environment that you use to travel. This is about 1 year of your working life. You are going to be breathing what you are breathing in the metro, in the bus, in your car. I spend 2 hours a day, so it's 2 years of my life I spent traveling in the train. So this is just to point out that the exposure of what we are breathing is not trivial. It is important, as Kjell knows. There are lots of works already about the air quality in the metro, because the metro is one of the most common transport modes. And this is only a selection of them. Please, if you have another one, don't worry, there are many more than this. But I just want to point out that one thing is there are huge differences between the concentrations of particles depending on the metro system, and also that the air quality is normally better when we are inside the trains than when we are waiting in the platform. The good news is that most of the time we are inside the trains. Really, in the platform, we don't spend a lot of time. So why I have been looking at metro so many years in my life, and why we are talking about this today? Well, the metro systems transport more than 100 million passengers a day in the world. The concentrations of particles are generally much higher than what we breathe outside. However, we cannot apply these limits because the indoor environments don't have a legal limit concentration, so we are not doing anything illegal. And the chemical composition of the particles we breathe is completely different to what we breathe when we are in any other environment. In the metro system, we are going to have different sources, like could be, let's see if it works now, like, right. It can come from the brakes, and these have different metals. It can come from the catenary, if it's electrical train, that it normally is. It comes from the erosion of the wheels or the rails, and also can come from outside. The concentration of particles coming from outside, it depends on the station, and we will see now. So what variables are affecting the air quality we have in the metro? This is, I'm going to say very quickly, but just to something that you probably never thought. The train frequency in the station. Normally, every time you are waiting in the platform, when a train comes this way, it's true, I can see it there, but I cannot see it here. Every time the train comes into the station, the particles concentrations go up, and then they go down, and then they go up. So each of these peaks is a train coming on the station, because the train pushes particles coming from the tunnel into the platform, and when it leaves, it sucks the particles as well. We also have the effect of the ventilation in the station. This is the most important factor of everything for the air quality. If we have a proper ventilation in the station, the air quality will be much better. The design of the station. We have done more than 50 stations by now, and we have seen that the worst possibility are the small stations with only one rail track. For example, you're thinking of London, you only have one track going there. So it's basically because the volume of air in the station is very small, so the concentrations of particles are bigger. If we have a bigger station with 2 rail tracks, then the air quality is better. And also, it's important the night activities. Every evening, we don't see this, but every evening they are doing things in the tunnels and in the station, and they are repairing lots of things that need to be repaired, and this is producing particles, but they are very high concentrations for a very short time that happen only in the evening, and when you open the service in the morning, in half an hour, you lose these concentrations. So what we want to do to know how to improve the air quality in the metro, in addition to know what possibilities we have to change, it's important to know which sources we should focus in. So we have analyzed the chemical composition of all the different parts within our producing particles, especially for AeroSolfd, the brake pads. And we see that the brake pads are, is this column here. You see the column that says brakes? You have high concentrations, especially of copper, of antimony, and barium as well. It depends on the type of brake. It's true that all the brakes can be similar, like Christoph said, you can have copper, but in the case of the metro, it's normally antimony or barium. So having this in mind for later, we are going to show the adventures to get this program.
So, hello everyone. I'm going to briefly go over the difficulties of implementing this solution. Not the difficulties, but the challenges of implementing these solutions on a metro system. First of all, I'm going to talk a bit before the project. Air quality measuring was already an important area in our metro. We already had 51 sensors for monitoring air quality. We would monitor PM 2.5, PM 10, carbon dioxide, VOCs, temperature, humidity, and overall, as you can see on the left, I mean the right side, the level of air quality in our stations in general is level 2 on the scale from 1, which is best, to 5 worst, which is considered good. Just to add that our metro, our trains are fed with third wheel instead of catenary. That's an important thing to add. Our role in the project was just to be a demonstrator. We offered 2 of our stations to field test the equipments of the AeroSolfd FD project, which was Alto dos Moinhos and Quinta das Conchas. Alto dos Moinhos first and then Quinta das Conchas. And then our main objectives were to go even further on the monitoring of air quality, and also explore more available technologies and solutions to investigate the chemical composition of the particles in the air in our network, even to assess the effect of our ventilation systems, of our mechanical ventilation systems in the network. The outcomes, we would be looking to generate insights to inform future air quality management systems, and to enhance whatever we have been doing until now. These were the installed equipments. We installed it depended on the phase. On the first phase, we installed 8 double units from an anomal plus 1 single. And then in the second, we didn't include the single, but then we installed the sensors from an anomal, the sensors from Cartif, and also the measurement equipments from CSIC and NFA. This was the Alto dos Moinhos station, which is one of the worst quality air stations, one of the stations with the worst air quality in our metro. Even though it's good, it's still one of the worst, and that was one of the causes to choose the station in the first place. Maybe because of the road above, the external factors influence a bit of the quality inside the station because of the ventilation and everything. This was the scheme of the station. We installed the equipments only on one side. It will be further explained. And then these are some photos of the equipment. As Francisco said before, the size of the equipment was indeed a challenge. The installation was not easy. That was in our warehouse, from the metro warehouse to when the equipments were being taken out of the boxes to the station, and then they installed the equipment in the station, which were, some of them were covering some heart in the walls, and it was also some problem in our. That was also some problem in our company, and then the 6 equipments there also. This was the second station. It was a way calmer station in a way calmer place, and this was this time we installed way more air quality sensors, kind of the same amount of air purifiers instead of 9 there were 8. And these were some more like the information to the clients, the equipments themselves, and then the CC and NFA equipments being worked by Stefanos on the right. And then the main challenges. It was not easy to retrofit because finding a suitable station is not easy. We have like problems with painting arts on the wall, which caused a lot of problems. Low ceilings in some stations. In other stations, there are really short platforms, and that can make it unsafe for our clients to install like a big equipment in a short platform. Then the size and weight make them hard to transport, especially in stations without elevator. And since the essence of our work, it needs to be done in nighttime because there cannot be people in stations, so all the work needs to be done at night. In terms of the testing phase, there was mostly positive feedback from everyone. There was engagement by the passengers. The passengers were curious. No one really noticed the noise of the equipments. And in terms of vandalism, which we thought it would be worse, there was just some graffitis in one of the equipments one time, or just some stickers, but it was not that much. And in the end, we can say that all the equipment was successfully installed, and there were no significant issues to point. I'll now present a video from the second measurement phase in Quinta das Conchas station.
O AeroSolfd é um projeto europeu financiado pelo programa Horizonte Europa e que visa desenvolver e testar soluções que procurem melhorar a qualidade do ar em ambientes urbanos. No nosso caso, no Metropolitano de Lisboa, estamos a testar soluções em espaços semi-fechados, com soluções de filtragem e monitorização da qualidade do ar. Agora que o sistema está em funcionamento, estamos a verificar o seu real impacto para ver se este tipo de soluções tem vantagens para melhorar a qualidade do ar nas nossas estações.
Fazer parte da equipa deste projeto tem sido uma experiência extremamente enriquecedora. É sempre interessante ver como essas tecnologias integradas estão a contribuir para uma mais fácil monitorização e possível contribuição para a melhoria da qualidade do ar nas nossas estações no Metropolitano de Lisboa.
Utilizamos instrumentação científica avançada que nos permitem quantificar em tempo real a quantidade de partículas que estão suspensas no ar nesta estação. Para além dessa informação, conseguimos obter informação relativa ao tamanho das partículas, à composição química e também à sua origem.
I'm here to investigate the air quality of this specific metro station and how recently developed air purifiers influence this air quality. To achieve this, we use appropriate equipment, such as the air purifiers which can be identified behind me, and different other instrumentation to obtain the appropriate measurements.
Este projeto demonstra o compromisso do Metropolitano de Lisboa e dos restantes parceiros para um ambiente urbano mais limpo e mais saudável.
This is it for me. I'll now give the floor to Teresa again. Thank you.
Thank you. I haven't seen the video yet, so that's good. Very impressive. I'm sure Martin will say that, but the help from the Metro of Lisbon has been incredible, and to want to participate and to allow us to do all these things was fundamental for the success of the project. So what have we done in Quinta das Conchas then, as Guillermo was saying? This time in the second campaign, we have learned from our mistakes on the first campaign. So we had many more low-cost sensors from Cardiff and Man and Hummel. We got a total of 27 sensors distributed all along the platform. And we also have in the place where it says number 4, in the corner, it's very slow here. We also have the CSIC equipment for monitoring and taking filters for chemical analysis. We have been measuring there for more than a month. So as you can imagine, we have tried everything and more. So the idea was to test how these 8 purifiers distributing along the platform can improve the air quality in the station. So we have tried using different number of purifiers, 4 or 8, running a different volume flow, full or half. Which locations we couldn't move the air purifiers, but we decided which air purifiers were going to be used. And also we have had different time periods for 24 hours, for 1 hour, for 30 minutes sometimes, just to achieve the best solution. In the corner where Stefanos was working for a month, or living for a month, we had all this equipment, basically measuring number of particles and mass concentrations. These are all different equipments that are going to give us different sizes of particles and concentration of PM2.5. And also we have equipment from NFA, the nanoscan particle, also for number of particles. In addition, we have a high volume sampler, that is this equipment on the right, the big box right of Stefanos. I'm sorry, but this is very slow. That allows to collect filters for PM2.5 concentrations. They were running for 12 hours in order to have enough mass for chemical analysis. So just to have an idea of what's happening in the station when you are there, this is the daily cycle for all the particles. And we are separating weekdays from weekends, because in the weekend you have less trains, so you have less people. And as you see, the concentrations are lower during the weekend than during the week. And we have used 2 sensors, one sensor on the left on the station and one sensor on red on the right. You see 2 things. One, that the main peaks occur in the morning in the rush hour from 7 to 10, and in the evening after 6 o'clock they start going up. And also in great shaded area, you cannot see it in the stage there, but it's an area showing from here to here when the ventilation is running in the station. There is a ventilation that runs from 7 in the morning to 20 in the afternoon. The rest of the time, the only ventilation the station has is the air that the trains bring when they come in. So this is the first week, no, less, 4 days, I think it was. The first 4 days we didn't turn on the purifiers. So this is what we call the baseline. Means this is the normal air you breathe in the station based on the 27 low-cost sensors. And you can see quite quickly, well, I put 2 colors to make it even easier, that on the right side of the station, you get concentrations between 55 and 65 micrograms per cubic meter. And on the left side of the stations, you get below 50, 55. So this has a reason, and the reason is, I'm pointing there, we have a red sector with higher PM and a blue sector with lower. And the main reason is that the ventilation in the station is run only, impossible. Sorry, it's the purple lane. You have the ventilation, correct me, is on the ceiling above your head, and it's only on the left side of the station. So that ventilation is obviously making an effect on the whole air quality of the platform. As I mentioned, remember the ventilation is only working from 7 to 8. So what about what we were breathing before we go into the levels? We took all these filters. This is not a filter. This is a filter from Barcelona, actually, with this nice color. The filter is white normally, and the Metro filters are red color, more like his T-shirt, more or less. And what we do is to analyze more than 60 compounds to see what the chemical compositions are. We saw that this is from the whole month, with the whole month measurement. So each point is one filter, and we see that most of the concentrations of PM2.5 is related to iron oxide. The iron is present in the wheels, in the rails, in the brakes, everywhere in the metro. So the concentration is not the same. I mean, PM2.5 is on the left vertical X, and the PM2.5 and the iron is on the left, but just to show that they follow the same trend. We also look at the antimony specifically because we know it's the tracer for the metros. We see it has a quite good correlation with the iron. Also, antimony is in nanograms per cubic meter, so the concentrations are very low, but just to show that they follow a similar trend. And also, interestingly, I point out that we also measure sodium chloride, that is the sea salt. We are in Lisbon, just to show that we have an effect of the air from outside in the station. So it depends, some stations are very deep and you don't see this, but in this station, we can say that some of the particles are coming from outside. We have done the PMS, the positive matrix factorization tool, to identify sources, and the best result was for 5 sources. One of them related to urban dust, mineral dust, resuspension of dust on the floor. Secondary aerosol, sulfate and nitrate. This has to come from outside. There is no source in the metro producing this. Marine aerosols also coming from outside. And then we identify the specific subway-related metal with all the metals, typically iron, chromium, manganese, copper, antimony, they were all there. And then there was a mixed source. It was very rich in potassium, and when we have seen this source somewhere else, it's based to biomass burning. When they are when they are burning wood outside, it could be related to this mass. If we see this in concentration, half of the mass of what we breathe in the metro is coming from particles in the metro, 48%. This is mass concentration. If we see individual filters, we try to see differences comparing the filters during the day with the filters during the night, the filters with air purifiers on, without air purifiers, and basically there are no differences. The concentrations of the elements are very similar all the time, and I assume this is what it should be, because the air purifiers are not prepared to filter specific sources. They purify, they clean all the particles, so they don't make an effect on specific components of the air we breathe. If you want, because we have 0 seconds, I'm going fast, so we can talk about questions later. So let's see now the particles and what effect we have seen with air purifiers. As I told you, we tried lots of things, but I'm going to focus on how can we see the best results. We did experiments, for example, for the working day, the filters that we say from 8 in the morning to 8 in the afternoon. And we have to separate again the blue sector from the red sector. But we see that in the red sector, in the higher concentrations where the ventilation of the station is not strong enough to clean the air, we got, even me, I cannot see the numbers, they are so small. We got concentration, we got a reduction between the baseline, that is in gray, and the blue, that means the air purifier is working. We got a reduction of more than 10%. It's a pity, I cannot make it work. Okay, so the blue is when the air purifiers are on, and the gray when they are not. And you see a reduction of more than 10%. Whereas in the left side, the blue sector, we don't see difference from the air purifiers working. In this case, the ventilation of the station is strong enough to clean the air, and the effect of the purifiers is not obvious. However, we say, well, maybe we want to try, we don't need to have the purifiers working all day. We can focus on shorter times, because that's also better for saving energy and consumption and money. So we did experiments for 2 hours, and we focus, for example, in the time from 8 to 10 in the morning. That's the rush hour when we get the higher concentrations. And you see in the red sector, we got improvements of more than 23%. We got a reduction when we have the air purifiers on on 23%. Whereas again, in the left side, we don't see much difference. It's the same. So what happens if we do 2 hours in the evening when the ventilation on the station is not working? Then in this case, in the red sector, we even got more than 30% improvement. But also you can see now without the ventilation how in the left side of the station, we also got a very nice improvement from the baseline to the air purifiers. In addition to reducing the average levels, like I saw the box diagrams, we also noticed in the meetings we had that the air purifiers are good in minimizing the high peaks. So if we only look or we focus on the top side of the data, that means the quartile 3, the 75% higher levels, then we get improvements of 40%. So more than the average, in addition to the average, the purifiers are especially good at minimizing all these high peaks that we have sometimes. So in conclusion, we noticed that like in the other metro stations, the distribution depends on the train frequency and especially on the ventilation system that the station has. And in the case of this station, we saw that the left side of the station where the ventilation is much better quality than the right side. This tells us that when we want to work on any metro station, each station is different and has to be looked at differently. You cannot just do the same for all of them. The air purifiers, we saw that they can considerably reduce the concentrations. In the case of having the 8 air purifiers working at full, we saw a reduction. And this reduction was greatest when the concentrations of particles were very high. And in the case of if we don't have any ventilation at all in the station, then the air purifiers are really good. We make a really improvement. So in conclusion, the use of the purifiers is potentially represent a social and economic impact beneficial for everybody, especially in those cases where there is no possibility of ventilation or where this ventilation is not distributed evenly in the station, or in specific times on the days when we have very high concentrations. So if we study each station individually, we can decide how many purifiers we need and where should be located. Thank you.
You can use this one if you are in the room here. Thank you to all the speakers. We are now moving on to the Q&A session, and that means the speakers go back on stage. And we also add colleagues who have worked more on the technical topics. So Katie Cadwell is going upstairs. She was responsible for the work package 3 from Mann & Hummel. Paul Henning from ZF is going to join, and you can see it's getting quite crowded over there. So luckily we have some colleagues who are joining online and are not on stage here. So that's Frank Pricken from the Mann & Hummel for the brake dust particle filter, the work package leader, and Lauretta Rubino from Word, CEO of Word, on the technical part as well. And they are online in case there are some specific questions. So, does it work? It works, and we have a second microphone, I think, one that we will bring for you 3 in the corner over there. And the floor is open for questions. Do we have some questions in the audience already? Then we need to start somewhere with questions. I was thinking at the urban aerosols are in focus here, and we want to look at them. Hartmut, we were working on the cities and looking at the different cities. We have Ancona as a hilly city at the sea. We have Valladolid as a city. We have the nice city of Ljubljana, and Gregor is in the place here from Ljubljana to tell more if you have some questions regarding the buses. Are there any specific differences or similarities on these cycles? Can you elaborate a little bit on that one?
Yeah. So what we see in general, I'm not sure, is the microphone working? Yeah, it is. Okay, perfect. That city buses have a very specific driving profile. So we see, or what's typical is a lot of still phases, like 30 to 35, sometimes 40% of the time a city bus is spending during its operation is standstill. This is common to all cities. In general, beginning from that, then you have a linear increase between 0 and 50 kph, and a very small amount of time the city bus spends above 50 kph, typically maybe during its or during the daily start drive from its depot to the operation area. So this is common to all cities. We saw some bigger differences depending on the bus line. For example, in Valladolid, we had 2 bus lines which were crossing straight the city. They had similar characteristics, but the other bus line, which was driving around the city on a circular road, this had a little bit difference compared to the other ones. But in general, you can say city buses all have a similar driving behavior. Regarding emission factors, the circular bus line was a little bit lower than the straight bus line in Valladolid. So that was an interesting finding for that one.
If you have questions in the room.
I'd like to know, and I don't know if the metro from Lisbon has that answer, and also what is the energy consumption of the filters, and what is the energy consumption of the ventilation, just to have an idea on what could be the savings of actually operating the filter instead of the ventilation. And the second question, maybe more for Teresa, is can we do those numbers in terms of dropping go to below 50? So the 10%, the 10, 20, 30% when the ventilators are not, can we decrease to what absolute levels of particles? Because I couldn't see from the graph. One thing is the percentage, and the other thing is what absolute levels we can reach. And the third issue, very simple, is it just the metros circulating, or is also the number of people in the station that may contribute to higher PM? Are we sure that it is the number of trains?
Is it working? So I'm going to be honest, I don't have the data here with me. I don't think if Tomé has like an answer for that, but you can.
So comparing the ventilation system of the station and the air purifiers, of course, the consumption of energy of the ventilation is higher because you have ventilation in the station and in the middle of the tunnel. So it's a bigger ventilation system. So the consumption is higher. And that's one of the reasons we only work at the most from 7 to 20, as Teresa explained. So also to reduce the energy consumption. On the speed of the ventilation is like stopped at the middle because it's it's enough for the usual particles, and there is the maximum speed that's only used when there is emergency, like if you have a fire or smoke in the tunnels to evacuate, to put the smoke outside. So related with the energy, of course, the energy consumption from the ventilation AVAC system is much higher than the air purifiers.
Let me add from a coordinator's point of view to that topic. it was great to have Metro Lisbon and have this station. It has an HVAC in one part, it has an HVAC in the other, not in the other part. And Metro was able to turn it on, turn it off. And we could run the air purifiers for an hour or for a full day. So we could explore a lot of opportunities when it makes sense, when it doesn't make sense to add a filter. When it has an effect, when it does not have an effect. And that's the challenge with the data, to look into what conditions we need to see something and what conditions the air HVAC system is already that strong that we don't have an effect that we can notice in the data. There is, of course, an effect because it's somehow cleaning the air, going through the air purifier, and Stefanos was walking around the platform to see that they are working. So all that is there, and this is a great playground to create a lot of data that we are now investigating, looking at. And one important thing before I hand over to Christoph, we have only a few air purifiers there. So the air exchange rate is quite low at that one. It's around 2. And that's coming to your question about, can we go to more reduction? Of course, if we know when to apply them and what air exchange rate we need for that one.
And yeah, I just wanted to add one thing. You asked about the energy efficiency of the air purifiers versus the ventilation system. And I think it's a very valid question, but I think in many scenarios, it doesn't really apply. Because think about what was the intention here. It was about retrofitting solutions. And where would you normally I mean, we had this very specific scenario of a or let's say a station with a well-ventilated part of the station. In most cases where the air purifiers would be considered are probably stations that do not have a ventilation system, right? And so switching on either or is not really an option. So you either have it, and then you clean it, and then you need to be aware of the costs, the energy costs, or you don't use it, right? So it's actually kind of balancing between the two is in most stations. I guess it's not really an option because they don't, where you would apply them is typically not where there is already a ventilation system.
Okay, thank you for that.
I have something to add.
We have some questions online we also want to address.
Okay, I just wanted to say that each device has an energy use equivalent to about a fridge. So they're quite energy efficient. And then also, as Teresa showed, 52% of the particles are coming from outside. So that is also coming through the HVAC system. So even having the HVAC system, sure, you have lower CO2, but you're not necessarily removing the particles. You're still adding more particles. It's just not brake dust necessarily from the traits.
So moving to the other solution for the brakes, there are two questions. One is, how do PM emissions compare between traditional brakes and regenerative brakes on electric vehicles? I think, Hartmut, that goes into the hybrid, if we have already there some data. And thank you very much for your nice presentation. Have you done chemical analysis of the PM10 brake dust with and without filter?
Do you want to go first, Hartmut?
I can start with the regenerative part. Yeah. So in general, definitely yes. Regenerative braking is reducing the particle mass emissions very significantly. We know that from passenger cars. We also conducted tests in Ljubljana with a hybrid car and saw that a significant part of the brake work or friction work can be taken by the electrical motor. So the friction brake or the foundation brake doesn't need to do that work, and with that it doesn't emit that much particle mass. In the field, it's hard to evaluate the exact amount. We can do that in the lab. For passenger cars, that's what we do on a daily basis. For commercial vehicles, that's something that wasn't investigated so deeply so far. But in general, yeah, regenerative braking is a significant reduction of brake particle mass emissions.
Yeah, and for the chemical composition, we did not look at the reduction of specific chemical compounds by the filter, and there's a very specific reason, because the chemical composition is dependent for each brake, dependent on each brake configuration, so it can be very different depending on the brake. What we do have, although we didn't show it here, is a size-dependent
efficiency of the filter. And therefore, if you want to apply it to a variety of different filters, and you know the size-dependent composition of the particles, you could use that curve to actually calculate which compound is filtered out with which efficiency by the filter. But here we didn't do it because we did it just for one specific break. And for the physical efficiency, so the particle size-dependent efficiency, the break doesn't really play a role. But then for the chemistry, that's very individual for each break, and that's why we did not do this here in particular.
Another question from the audience.
Hello, and my name is Adnan from EIT Urban Mobility. Thank you very much for all of you. I think it's very interesting to see the work that you've been doing. My question specifically to Christoph, I believe, as a follow-up, I saw that you had the graphs of the toxicology, and I saw that you consider different types of brake pads. I know that, well, I understand that non-asbestos organic brake pads are being considered for their low PM number participation, basically. And I just wanted to see first, did you notice any difference in terms of toxicology in comparison to other types of brake pads? And then the other thing, did you look at the PN number differences between different brake pads, brake pad materials?
Well, first of all, I should say those were not our data. Those were from a publication. So I haven't done these. And that they, if I remember correctly, they didn't describe exactly which brake pads they are. I mean, some were organic, some were metallic, some were semi-metallic hybrid materials. What the graph showed was actually that the organic pad materials seem to have higher toxicological effects than the metallic ones, which was a surprise for me. I would have expected it the other way around, but that's what the data show. And I should mention, this was actually not a toxicological study that they did, but it was kind of a review article. So they reviewed a whole list of different studies and summarized them with these graphs. So yes, there is a difference of the toxicological effect dependent on the brake pad material, which is something that's currently not taken into account in the legislation because they only look at the mass. But it may be, and it should probably be double-checked, that although a brake emits less particles, it may trigger higher effects, depending on what the graph actually showed. Concerning number emissions, we did measure them for the with and without the brake dust filter, but I showed you that at low velocities, the brake doesn't really get very hot. And if the brake doesn't really get very hot, it doesn't really generate a lot of small particles. In fact, it didn't generate small particles. So the number concentration is not, in this case, and on all the cases that we looked at, we're not dominated by the thermally generated small particles, but it just reflects the larger particles. And the larger particles can equally be represented by the mass concentration. And that's why here we only looked at the mass concentrations. Right? And this is why for urban driving, we mainly see the mass, so larger particles being emitted. And that's why the mass is probably also the most relevant metric in this specific case of the brake emissions. Doesn't necessarily apply to everything and all the brakes, but here, that's why we're focused on mass.
Thank you. Looking forward to another question in the audience. Please state your name and...
Thank you very much for the very nice presentations. My name is Thanasis Dimaratos from Aristotle University of Thessaloniki. I have a question for the filters, both for the brakes and the tailpipe. For the brakes, if I understood correctly, the filter covers a significant area of the disc. So my question is, did you observe any impact on temperature of the disc with the filter? And for the tailpipe, if I understood correctly, the filter that has been used is one of the latest generation filters that are used also for first installation, original installation of vehicles. Did you run any optimization in terms of sizing for different applications, and did you observe any impact on noise of the exhaust gas? Thank you very much.
Shall I start with the brake dust filter? Maybe first on the dyno, then on the field, and then go over to the exhaust solution. So make it short. Yes, on the dyno we observe an increase of temperature. I have to look up the exact numbers. It's approximately 20 to 30 degrees Celsius average disk temperature, which is increased by the brake dust particle filter. Yeah.
Just to add on this, so is it possible that because of the filter, the disk exceeds the transition temperature? So
That case is possible. Yes, it's possible.
Yeah, from our side, we have this also on the dynos on a different view on the extreme tests to validate the mechanical durability, the impact on the brake performance. And also here, when you do extreme tests, you have around 50 to 80 degrees higher temperatures, but still in a range where you can accept it, so nothing happens on the brake performance. Yes, and when you have an increased temperature, also the wear is a little bit higher, but still, as we saw on the results from the PM10 dyno, it was still in reduction by this 38%.
First question about generation of the GPF. The GPF that we used is what is currently being used for OEM. Whether that is the latest generation, I don't know, but it's the one that's called GC 2.0 from Corning. Second question is related to the first deliverable, the matching of vehicles, because we did a thorough investigation of how is the fleet in Europe designed when it comes to the Euro classifications, to the size of engines and the frequency of the different vehicles and so on. And an integrated part of that matching was also to investigate how many different filter sizes did we need to accommodate these type of vehicles. And the conclusion was that we ended up with two geometries based on the same technology, one for the large engine group and one for the small one. And there is not a big difference between the two filter sizes, but in order to optimize back pressure relationship between the engine and the volume of air going through, we ended up having two geometries in two volumes of filter. Sorry, impact of noise is an integrated part of making a TRL thing and also to achieve the TTG approval in Germany. So noise has been measured for all the vehicle configuration and was part of the approval process with KBA as well. And noise testing has been done in Switzerland, and it's been done following the KBA rules by TÜV. And no increase.
So there is a question about how to scale up, how to apply it to different environments. And I think that was in the brake dust somehow mentioned already, some other urban vehicles. Perhaps Paul, or who can apply for the brake dust particle filter? What is potential application range in future, where to go?
So regarding this brake dust filter, what we have seen here on the pictures, it can be scaled up for probably all heavy-duty vehicle classes, up from 7.5 to 44 tons. So there are mainly three different ranges, 17.5 inch, 19.5 inch, and 22.5 inch. This exemplar, what we have here on the tested and investigated, is 22.5 inch. So a heavy truck or bus application, but it's scalable to the other classes as well.
Yeah, and we have the procedure now, how to get a type approval. And with that, it can also be applied to different other brakes. That's a big step. That was in the past some hurdle that there was no procedure with the German motor authorization to get an approval. And now it's there, and now the products can be brought to the market and to other places as well. And last, for the tailpipe solution.
Part of the TRL8 compliant requirements of deliverables, we made a quite a comprehensive document explaining how different designs could accommodate the different vehicle configurations in reality. And I must say, to start with, that it's amazing how many vehicle configurations that exist within the same type of vehicle. A Golf 7 platform may contain 6 or 7 different configurations depending on country and application. So there is a lot of work associated with configuring that standard modular system to cover most of the configurations in order to make it scalable. That is a known type of work also from Retrofit in the old days. It should not be underestimated, but it's doable. And I would think, and now I'm guessing, that with 15 different application development project, you should be able to cover 80% of the fleet. There will be a fraction of the fleet that you cannot cover. And basically in our documentation, we have described 4 different design cases. One case is the easy one that I just chose to show you today. That is where you cut out a piece of pipe, put in the filter instead of that piece of pipe, and then you clamp things together. Second one is where you combine the system by taking out one silencer, and then you replace it with a filter without compromising noise attenuation, of course. Second use case is where you have to make a combination of the filter module and the silencer thing, not to violate the sound attenuation requirements. And then the fourth use case is where you have to rearrange the whole exhaust system depending on very restricted space envelope on the vehicle. But the golden rule is, do never ever change the position of the three-way catalyst, because then you will compromise the parameters under which the vehicle was homologated, and always put the filter as close to the three-way catalyst as possible, and make sure that you're not compromising any health and safety issues concerning surface heat of what you apply. So that means insulation and the correct hanging and clamps and gaskets and so on. So basically, application development to scale thing is a necessity, and as in anything in business life, do as much as possible with the least amount of variation. But it's always a compromise.
So you can see the colleagues online, and moving forward, there is one question that I saw online, and it's a great question. What is the main input that your results would give towards policymaking, local, regional, EU level, main gaps and barriers? This is a great question, and that leads to the next session, session 4, where we will look at the next steps. So for now, I would like to thank the audience, the panelists, and for the technical presentations, and for being here on site and online. And we make a 5-minute break here, because we need a break, and we will reconvene, I think, at 5 minutes to 3. Next steps, what the impact will be, what is missing to go for an implementation. We had good questions in the last session, and we will follow up them. What's also on EU side, what is more going global, what can be done, and we have a list of interesting speakers. But before we go there, a quick recap for those who are joining this session, and for the others to remind you that this is the final event of the Fast Track to Cleaner Urban Air. So it's a fast track to implement and to get to solutions that can be used as market-ready solutions for cleaner urban aerosol. And it's the project AeroSolfd, because we are solving that one by market-ready solutions for tailpipe brake emissions in semi-closed environments with filtration devices. So this is a collaborative research, and we have done that with partners. We have developed the solutions, and you have had the chance to see the technical presentations in the sessions before for a tailpipe, for a brake dust particle filter, and for filtration solutions at a metro station. We have collaborated with partners who are measuring the emissions at the location. We have also looked into a life science and overall sustainability assessment. That was a specific session 2. That's still ongoing work. We will finish until August, so please follow us on LinkedIn and look for deliverables and publications. There's some nice work also going on relating that into numbers and some data that can be easy understood. We are on that way. You saw some ideas today that's still working. We also discovered that it's a little bit tricky and you need to know what model you need to apply for the sustainability. If you just go with the standard, you might miss an opportunity of having a positive effect because everything is related to one side and there are multiple factors that you need to take a look at. So that's also a great outcome of that. We have done demonstrations. We had the chance to look into different cities and look at an urban braking, and that's what we had in the technical session before, that the cities are quite similar, but it's different to a cycle that's used for overall assessing braking of cars and including the long haul and the cross country and some higher speed. So it makes sense to look into the cities also from the physics, because the braking temperature is lower and there is more PM10. So this can apply to more vehicles in the city. This can also be garbage trucks or an urban fleet of trucks, delivery trucks. So there is a potential to retrofit to do that. With a Metro Lisbon, we had the opportunity to have a nice, from a scientific point of view, a great setup, because you could try a lot of things out and you could see what works, what is good, how to add it, and we will hear later a little bit on the reflections about that one. And with Steinbeis, we have a partner here who is organizing this event and who is also helping us with communication, dissemination, and look forward to the LinkedIn posts. These are the solutions. We have all 3 in focus because they are different options for the cities and they might have different paths to implementation. So with that, I would move on to the next slide. That would be the agenda. We are coming to the end, but the end of a session that's ready to retrofit. So it should not be the end, it should be the starting point, because now we have something that's ready to use, and that's what we are going to do with this session here. We are looking what is missing, what collaboration would be great, what other options are there to have a fast track, to have something that can be used. We have seen that in the citizen science and the why that citizens are looking for better air. That's something that's important for them, and that we have now some solutions that can be applied. And I'm very happy that for this sessions we have EIT Urban Mobility joining, we have also our sister project Vera joining, and we have Meka Rastro-Bresny from the advisory board. He is located in US and joining online, giving us a broader picture, looking at what can happen and what we can do with that. With that, I would like to open the special presentations on how to accelerate cleaner mobility in Europe and to give an overview about EIT Urban Mobility. That's the 3rd pillar in the framework. We are with a project in the 2nd pillar, and when it comes to implementing to market, they are the right partner. We had some exchange with the AeroSolfd project as well as some other good exchange. So I'm very happy that Adnan Abdullah is joining us here on site and has been here all day asking questions and being very interested. And the floor is yours for a presentation about EIT Urban Mobility.
Hello. Thank you, Martin, for the invitation and for the excellent organization. Yeah. So it's been very interesting to see like all the work developed both in AeroSolfd today, but also in the sister project Vera in this field. And I think one of the interesting parts about this whole event is the organization, the story being told. What is the problem? What can we do about it, and how can we move forward? So I'm here, I'm part of EIT Urban Mobility. Our mission is to make urban spaces more livable, and that means healthier air quality is a key aspect of what we do. So
a first question is, what is EIT urban mobility? What is EIT first? For those who are not familiar with it, the EIT is the European Institute of Innovation and Technology. It's part of, it's a body of the European Union. It belongs to Pillar 3 of the Horizon Europe framework. And it is basically, it sets up a few different knowledge and innovation communities or companies in various fields. We are the ones specialized in urban mobility. We are one of the largest European innovation communities, or the largest European innovation community in the field of urban mobility. We work with public and private stakeholders to bring about the change in the field. And we have presence pilots in various cities across the continent. Again, as I said, health and mobility, air quality is one of our key focuses as part of the health and mobility vertical, and that's why I'm here today. So one of the things that I want to focus on, and I have a few slides, so I'm gonna jump through them. And if you have any question later, please ask. But one of our key objectives is basically match and connect. There's a lot of knowledge, there's a lot of solutions, a lot of technology being produced all over Europe, both through Horizon Europe projects, but beyond. And our goal is to bring these solutions into the market and to bring them into real life, to make them actually do what they're supposed to do. And we do that first by creating a dialogue, bringing partners together, and bringing this innovation, this conversation further. But we also do that through mechanisms, through tools. So we have, for example, in the innovations to market, we have calls that push the TRL level. We've seen how a lot of these solutions are reaching TRL level 7, 8 through the Horizon Europe, for example, project. And we try to push them to bring them into the market, providing both connections, but also funding. So I'm not going to bore you too much with some of the key numbers and the presence, but I wanted to focus specifically on some of the work that we've done this year. Specifically, we focus in the area of air quality on a niche topic, which is the non-exhaust emissions. And when I said non-exhaust emissions, that means 2 of the 3 solutions that we've seen today, the ones for brake, but also the ones relevant to the closed and semi-closed environments in the case of the railway industry and underground. One project that is very interesting that is happening at this moment is in the London Underground and Paris metro station. And these, especially in the case of London, we've seen in the figures presented by Teresa, how London is one of the situations where it's a bit high because of it's an old system. A lot of the challenges that they have there, especially in monitoring and resolving the solution. So this is a project that looks into the great ways in which they can properly monitor their PM air quality. Another project looks at the tire. So it's another one of the non-exhaust emissions for road transport, which is the tire abrasion problem. And then in addition, we've also done a study, and this study was commissioned and was commissioned by us in collaboration with Greater London Authority and TfL, and was done with one of the partners in the Vera project, Emicia, and briefly, I think I have some time, so I'll briefly present some of the results of this study. So in a lot of contexts, I think a lot of you here are aware of this already. the non-exhaust emissions are becoming a larger chunk of the problem from road transport, and we've wanted to see the sources, the key factors, the chemical composition, interventions, possible interventions, and then recommendations for policymakers. And we've done that by looking specifically at the case of London. I'm not going to go into these ones because I'm sure you're aware of most of this information, but I'll go directly to the interventions. And a lot of the times the intervention is not one. There are different things that can be done. Some of them are technical, like we've seen today. Some of them are more at the policy level, and some of them are a combination of both. And we've selected a few different, so the consultancy selected a few different ones, and we've done and have done a cost-benefit analysis, and in some cases just the benefit, net benefit analysis. And these interventions that were selected were mode shift, electrification in changing the travel behavior, and then technical interventions that are reducing at source, so wear-resistant material, both for brakes and for the tire. And then mitigating once emitted, which is the filtration devices. All of these solutions were registering benefits, but we've seen the largest benefit is from low-emitting materials, both in the case of brake and tires. Combining both of them gives the highest cumulative benefit. And then these are the scenarios to the left are the ones that looked both at the cost and benefit, and then we have the other one, the scenarios that looked mostly at the benefit, because it's a bit harder to look at the costs. In terms of, we've seen that modal shift in cities is actually one of the biggest possible contributors, and then combining that with faster electrification increases by about 20% the benefits. All of this, you can find them in our website. We've published the study. We've published also the Power BI tool, where you can compare different scenarios and look at the different results. And that's it. In terms of recommendations, I'm gonna select a few different ones, but for me, it's also one of the most important one is recognizing the problem, right? A lot of the times, like in conversations that we're having in these closed circles, where all of us sometimes are aware of the problem, but many times we have conversations with city leaders or citizens, they might not even be aware of this conversation. That was the case for me, at least, before joining my company, before starting to work on this topic specifically. So there's also a lot of work that needs to be done into passing the knowledge to the general public, and recognizing it, at least for the policy makers and for the city representatives. And then obviously there is work at the internet. So there's the local work, and then there's also the international work. So developing more standardized monitoring and measuring protocols. We've seen that, for example, Christoph, I believe you shared the Euro 7 table that is still 90% empty. So that's also one of the tasks that needs to be worked on further, both in the case of the tire and the brake problems. And then at the national level, we need to promote and support these solutions that are creating immediate effect. We need to support them effectively by policy, by incentives, etc. Another thing that I also want to bring attention to is that we need also to be careful not to have skewed attention, is lowering, for example, PM at the cost of higher toxicity, or that kind of things that we need to be careful with. So this is what we've done, and now it's perhaps with the 3 minutes that I have left, I'll talk a bit about what can we do in the future. And as we have, as I mentioned, several tools in our toolbox at EIT Urban Mobility. One of them is trying to bring you together people from different projects, both AeroSolvd, Vera, but beyond, in conversation with our partners, and both to raise that awareness, to share the learnings, when a solution is relevant. We've seen one of the things I really liked, for example, is in the presentation about the metro solution, is there are situations where the solution is most relevant, and that knowledge needs to pass to the different players in the field, the different metro systems, the different underground systems. So that's one thing that is part of what we do. But we also provide funding, and one of the cases is the Strategic Innovation Open Call that we've recently launched. And this is a Horizon Europe call. It's a competitive call, but it's usually smaller in both size and scope than the Horizon Europe project. On the other hand, our goal is not mostly research, but is to bring these solutions, these learnings, and the most successful of them, to bring them to the market, to bring them to the final user. So we're talking about pushing the TRL levels of the solution from 6, 7 to the 8, 9, and 9 specifically. And we do that by this call, for instance, where consortia are much more smaller. We're looking for a minimum of 2 partners from 2 different European or EU member states and associated Horizon Europe countries. The duration is only up to 2 years. And the funding is up to 2 million. This is a smaller funding than the Horizon Europe project, but by partner is significantly higher. And that's it. Our first cutoff is in September. So this is a call for you to for those solutions that are almost there, that have a clear niche or that have a clear orientation or problem to resolve. This is a call to get in touch with us, and we'll share more information about it. I have more slides about it, but I also have only 33 seconds, I see. So yeah, I'll leave that for the questions, if any, and for networking afterwards. And that is it from my side. Thank you very much.
I guess I need to repeat it here. Thank you very much for that insight, and also giving the opportunity to ask questions, because you didn't talk about all the slides. So if you catched up something, you can ask that later in this panel discussion. We are now moving on to the next part. That's our sister project, and that was one of the last slides. That's all about collaboration, and this is also great. We have some same solutions, some similar, some complementary offering, but addressing the same point. So it's a pleasure that you made the steps to come here directly from the General Assembly of Vera to this place, and that you are lucky to got a good flight back to your home country. And having you here, it's fantastic. So the floor is yours.
Thank you very much, Martin, for a nice introduction, and thank you very much for the invitation. It's a great pleasure to present here the Vera project, the sister project of AeroSolvd. Vera stands for Vehicle Emission Retrofit Activities, and it consists of a consortium of 17 partners from 10 countries, where we have technology developers for the different solutions. So starting from tailpipe retrofits, we have Monolithos from Greece for light-duty vehicles and DNEX from Germany for heavy-duty vehicles. While for brake retrofits, we have Brembo from Italy, focusing on road vehicles, and Talano from France, focusing on both road vehicles and metro. We have some engineering companies, some research organizations, some service providers, and also Metro de Madrid as a fleet operator. Very quickly, the structure of the project and the objectives actually are in three pillars, starting from the first objective that has to do with tailpipe retrofit solutions, aiming at developing full-scale systems that are demonstrated on vehicles, targeting both particle emissions, but also addressing gaseous emissions. So we are actually developing coated filters. The second objective has to do with brake retrofit solutions, where we are exploring two different solutions. One is to reduce the produced particles through coated discs and pads, so alternative technologies of discs and pads, and the other is to filter, to capture the produced particles through filtration systems. And the third pillar of the objectives is actually to assess the overall impact of retrofit solutions and quantify the health benefits through a cost-benefit analysis. I will jump directly to the presentation of some first results, making also some reference to the methodology that we are following. The first thing before developing our systems is to examine what currently exists on the market, on the retrofit market. So we made a thorough market investigation. We found relatively limited availability of retrofit systems, most of them tailored to specific vehicles. So we tested one of them on a plug-in hybrid vehicle. You can see the installation of the system in the figure. The filter was very efficient. It had more than 90% PN filtration efficiency without any impacts on CO2 emissions. And of course, since it was an uncoated filter, it didn't have any impacts on emissions. Starting from this, we started the development of the tailpipe retrofit solutions within the Vera project. So we are considering three use cases: a passenger car, which is mainly fueled by natural gas and also has as a backup fuel gasoline. So we are testing the system with both fuels. The interesting thing here with a specific vehicle is that since it is homologated as a natural gas, it is not tested with gasoline when it is type approved. There is this small window in the legislation. And we are highlighting this because actually when it runs with gasoline, it is a GDI, so gasoline direct injection, without a filter. So it was interesting for us to investigate what happens with this case. Although a niche market, still there are some GDI powertrains without a filter. And then we are considering a light commercial gasoline vehicle, a Euro 6B. I can mention also the models. The first one is a Skoda Octavia, a latest Skoda Octavia. The second one is a Citroën Berlingo, so a small light commercial vehicle powered by running on gasoline. And the third is a natural gas bus Euro 6. We have developed the systems. You can see already the installation. The one is the Citroën Berlingo. I don't know if I can use this. Okay, this is the Citroën Berlingo, where actually we just replaced the silencer. And this is the Skoda Octavia, where together with the filter, we had to add an additional muffler in order to cover all the requirements in terms of noise. We are following a combined methodology to develop this, so testing and modeling at small scale until we come up with the preferred solution in terms of filtration efficiency, pressure drop, and also catalytic activity. Here, an indicative result of the filtration efficiency. So this diagram presents the cumulative particle number emissions during a cold WLTC, and the reduction is above 19%. This goes for light duty vehicles, where the pressure drop was not increased as compared to the original muffler that has been replaced by the retrofit system. Moving to brake retrofits, we are considering both road vehicles and metro applications. Starting from road vehicles, we have 3 use cases, 2 passenger cars and 1 light commercial vehicle, while currently we are extending also to heavy duties, although that it is not mentioned here. We are investigating 3 different retrofit solutions, starting two of them are developed by Brembo, looking at the materials of the disc and the pad. And the third one is a filtration system by Talano. We are testing the solutions starting from the laboratory, so on the brake dyno, in order to investigate performance, NVHs, and emissions, and then we go on the road with a light commercial vehicle that it is equipped with the necessary instrumentation in order to measure emissions and also collateral effects in terms of handling and safety of the vehicle. Concerning metro and train, we are considering the 2 different brake systems of metro, so the disc brake units and the tread brake units, where we are developing the filtration system for both cases, and we are testing on a brake dyno both performance and emissions with the filtration system. Some indicative results with the first solution developed by Brembo with different pad and disc materials. We measured emissions, PM10 and PM2.5. These are results from the brake dyno. And we observed already a reduction from 80 to 90% with the discs and pads. Maybe I forgot to mention that the idea is to test individually the different solutions and then combine the best disc and pad set with the filtration system in order to see the combined effects of the retrofit solutions. Apart from the brake dyno, we are running tests on the road. This is just the baseline test that we run with the vehicle in order to have the starting point. Since time is running, maybe I can proceed to the next slides. And apart from the technical developments, we are also considering the impacts in terms of environmental and cost-benefit impacts. So we are starting with, we are considering physicochemical characterization of emissions in order to better understand the composition of particles. We are also running toxicological analysis to better understand health effects, as well as air quality assessment and exposures, particularly in confined environments. So we have run some tests in metro stations and in bus terminals, also with colleagues equipped with portable equipment in order to investigate spatial distribution of emissions. This is just an example of the measurements that we did in 2 stations of Metro de Madrid and in the Amsterdam bus terminal. And all these provide input to the cost-benefit analysis of the retrofit solutions, considering a degree of penetration of these technologies to the fleet, and finally concluding to a quantified impact of these solutions. Last slide, and going a bit beyond the project, one of the partners of the consortium, Monolithos, is developing some innovative solutions, particularly as concerns 3-way catalytic converters, and these technologies incorporated in the filtration system, in the retrofit solutions of the Vera project. And recently they received the type approval. Their main innovation is that they replace PGM with copper, and recently they received a type approval, which is practically the first copper-based homologated catalyst for automotive applications. With this, I close and thank you very much for your attention.
Thank you very much, Thanasis. Great insights, and we will come back to that later in the panel discussion. It's now a keynote from our advisory board member, Rasto Bresny. I met Rasto at an SAE government industry meeting in the US, and MECA is well known for cleaner mobility, and we were very happy that we could get you on our advisory board and that you are here now to tell us something about the achievements, next steps, and looking forward. Have you online here? Greetings to the US.
Thank you, Martin, for that kind introduction, and also for giving me this.
Can you wait a second? We need the sound to come up here.
Okay.
Can you start again, please?
Sure.
No, it's not working at the moment. We are in face contact with the technicians, so...
Testing.
Perfect. Test is always good. It's running now.
Well, thank you, Martin, for that kind introduction and for giving me this opportunity to join this conference virtually from Washington, D.C. I'm the executive director for MECA Clean Mobility, and I'd like to share a few of my thoughts on kind of the achievements as well as the next steps of this project based on learnings that we've had over the years. So for those of you who are not familiar with MECA, we're a nonprofit trade association that operates globally but is located in North America. And for 50 years, we've been representing the suppliers of technologies that reduce the environmental footprint of vehicles. All mobile sources, basically, including passenger cars, heavy-duty vehicles, and non-road equipment. So if those of you who are fortunate enough to remember what happened 50 years ago, the first catalytic converter was actually put on passenger cars in the US. And so since then, the definition of clean mobility has actually evolved quite a bit. And as we went beyond the after treatment in the tailpipe to regulating CO2 emissions, we added technologies that are on the engine to reduce the fuel consumption and reduce CO2. And then most recently, we added the latest technologies, latest powertrains that are electric and hydrogen for fuel cells and battery components, as well as the power electronics that go on those vehicles as well. Going upstream, some of our members are also providing the infrastructure and chargers for charging those vehicles, and then downstream, looking at recycling of battery materials in order to reduce the critical impact of rare materials. So the reason I feel that this project is so critically important is because that in order to accelerate our air quality goals, it's not enough to just bring in clean new vehicles, but we also have to address the in-use fleet. And the reason for that is that the average age of cars in Europe as well as in the US is over 12 years old. So what that means is that it takes about 20 to 30 years to turn over the fleet to the newest vehicle technology. And so you can see across Europe, some of these vehicles are actually approaching 16 to 18 years average age. So the other thing that's important is to look at policies to look at parallel approaches to transitioning the fleet. So not only electrifying the fleet, but also, for example, in this case, deploying GPFs on all of the ICE vehicles. And this is shown in this right-hand figure, which represents some work that MECA sponsored a few years ago, where we looked at a scenario where we're only bringing in electric vehicles, and for example, a target of 100% new vehicles by 2035, 100% new electric vehicles by 2035. The ICE vehicles that are on the road still emit about 30,000 tons of PM by 2050. If we delay that introduction by 5 years, we emit an additional 15,000 tons by 2050. However, if we do a parallel approach and introduce electric vehicles as well as GPFs on all of the ICE vehicles, we reduce that PM emissions down to below 5,000 tons by 2050. We've seen some of these devices, and excuse me, Lars, I think showed you some examples. I just want to look inside here and show why this wall flow particulate filter is really the best control device for tailpipe PM. And you can see these horizontal channels which have plugs, alternate plugs, that allow the exhaust to pass through. However, the particles are captured on these porous ceramic walls. And what that does is it gives us a very high filtration efficiency, over 95% for PM, even higher for ultrafine particulates. However, because the PM has also toxic components associated with it, such as polycyclic aromatic hydrocarbons, those are also reduced with a very high efficiency, and black carbon, which is a major component of the PM, is also captured. And because it has a global warming potential of about 2,000 times that of CO2, it has a great impact, especially on the short-term climate warming. So there have been a number of studies done already in the literature looking at individual vehicles. However, I think what Vert did was really important by looking at a fleet of vehicles, different vehicles with different installations, to show how this technology is very versatile. So a study that the other unique feature of these filters is that they operate under all driving conditions and all ambient temperatures. Unlike catalysts, which require temperature to begin to work, these particle filters, from a study that Mika sponsored in California on a vehicle, you can see that with the GPF, you may not be able to see these, you might not be able to see these orange lines, but those are the GPF emissions on this vehicle, whether it's operating at slow speeds in city driving, high speeds, highway driving, or climbing mountains, that it's capturing the PM at over 95% efficiency. The other thing that's very unique about particulate filters is that they actually filter better as they age. And if you look at the results of this study by Umicore, you can see that on an engine, just engine out emissions actually increase over 160,000 kilometers by about a factor of 2 due to engine wear, oil consumption, and so forth. The filtered tailpipe particles actually decrease over time because the ash that's captured in the filter helps to improve its filtration. So I think both Vert and Mika have a lot of experience over the years, decades of experience with diesel particulate retrofit, and there's a lot of learnings that we can benefit from when applying and implementing gasoline particulate filters. So diesel retrofit programs have provided policymakers with an important tool to actually accelerate the air quality goals by cleaning up the in-use fleet. And similarly, on gasoline vehicles, this would be the case. And there's some important considerations as we think about implementing retrofit programs. I think it's important that the devices that are sold in the market are verified by a regulatory body or testing agency for both their performance and durability. It's also important that manufacturers provide both a device and installation warranty to not only provide confidence in the technology, but also to protect end users to make sure that they're getting reliable devices. Application engineering for the specific vehicles and a professional installation is also a key to success, to make sure that the systems are performing to their maximum. Doing a vehicle pre-installation to check and make sure that the vehicle is a good candidate, that the engine is operating properly, it is well maintained, will also improve the success of these retrofit solutions. Once the technology is deployed on vehicles, having an in-use emission inspection is important to prevent tampering and also ensure continued compliance with the goals. And finally, as was mentioned earlier, incentives are really a necessary component to motivating consumers to retrofit their vehicles. And this can be in the form of monetary incentives or access to zero emission zones and things like that for vehicles that have the technology. So with that, I want to thank you for your time and your attention, and I'll look forward to our discussion during the panel.
Thank you very much, Rastro. With that, we're now moving to the metro stations, and we are looking at reflections of a metro operator. Tommy is joining us here from Metro Lisboa, giving us some insights and something on the next step. The floor is yours.
Hello, everybody. Good afternoon. So I will give a short presentation about some insights and learning lessons from these two testing at the Metro Lisbon stations. So a short presentation about Metropolitan Lisboa. So it's a mass transit company in Lisbon that operates a metro with 4 lines. So it's a medium system. But we are now in expansion phase, so lots of a circular line, the station of the red line to another places in the city, and also the violet line that is a light rail. So this is a new related with the traditional mass transit of Metro Lisboa, but a different transportation. So we can get more information about in our website. As my colleague Guilherme explained, so the air quality, it's a matter that is for some years very relevant for Metro Lisbon. So it's important because for our passengers and works to have a well-being. So we have clean air ensures that the transportation it's comfortable journeys and better working conditions. Also be related with the public health and urban resilience. And also, of course, we have this need to have a strategic and policy alignment, especially in the morning. Francisco explained the new regulatory obligations that the urban development and environmental responsibility the metro operators must have. So, of course, as also Guilherme explained, we have several monitoring stations that classify the number of particles in different and also other chemical compositions on the air of the station, as we refer here. And the air quality overall, it's good. So, but it depends of the stations, of course. So, but here this theme of air quality, it's difficult sometimes for the metros because it's and this is some of the why. This is an area that sometimes when you don't work in this type of environment, sometimes you don't understand. But we have multiple pollution sources. We have air from outside, but air also from the maintenance operations, like the griding, that it's done at night, the cleaning operations, and also the train operations also release particles from the railways, etc. So it's a dynamic. So, and Teresa and Guilherme also explained this when they talk about the work package 3. So it depends a lot of the hour of the day, also the number of passengers in the station sometimes, and also the ventilation of each station that creates complex airflows. Also the airflow from the city. It's very relevant. So we think sometimes the air from the city influence in the negative way the underground air quality, because it depends also the position of the ventilation system, the ventilation shafts of our because sometimes we have near roads and the particles from the brakes from the cars enters in our system. So the air quality, and we have this on the first testing season, the Sahara dust influence on a negative way the testing on the first last year in the first season of testing in Altos Vinhos station. Also, it's a very complex infrastructure, so and we see these on the last season. We have like different parts of the station and the geometry of the not only the station but the access points for the escalators, the stairs can hamper and sometimes efficiency air circulation. We also have like the legacy ventilation system. So it's sometimes older systems can lack capability or flexibility to meet current standards. So we have different generation of stations. Of course, the last stations are better, more powerful ventilation, but sometimes the older stations, the ventilation has some difficulties, and that way the retrofit solution, the retrofit equipment like AeroSolfd can be a solution for that. Also, the retrofit stations. This is sometimes the persons not to choose the stations that we use in the AeroSolfd project was difficult because there are several limitations to put the equipment because of the space limitations of the platforms. Also, the architectural integration, like art in the walls. Sometimes you cannot put the equipments in that position because there is something art pictures. You have the marketing tools, so lots of limitation, and also the security. The guys from the security area sometimes also give us limitations where we not put the equipment these because they have some the cameras cannot capture people that are below the equipment. So lots of limitations that constrain the retrofit solutions. So what do we think for future applications from these preliminary results and opportunities for the use of this type of equipment from filtration and also monitoring? So sometimes it can be used in temporary ventilation reinforcement. So when the AVAC system from the station, it's not enough, we can use this type of solutions, and especially when we have planned works that can promote a higher number of particles. So also target improvements, so apply on specific parts of the station, like some atriums or some stairs that the actual ventilation is not enough, and on that specific space, the air quality it's a little it's higher than on the platforms. Also, this is an idea. If we have like a portable filtration units, I don't know if it is possible because these filtration units are powerful but very big and difficult. We have to fix on the floor, sometimes on the wall, so it's not easy to move these. If you have something like it's a portable filtration units, can be interesting to put on specific areas or in temporary events. So also and the question before is about the energy efficiency. So we have these for the AVAC system, but we have to study this for these air purifier solutions. So, and also for the new stations to have better understanding of the airflows and to have like a design guidelines and refurbished stations. So what can we do for new stations, but also when you try to refurbish stations where we can integrate these type of solutions. So this is a image of Lisbon. So together we can achieve a healthy and more sustainable air quality in our cities, and this is very important. So because good air makes great journeys. Thank you.
Thank you very much. You can already stay over there because we are now starting with a panel discussion, and I like to welcome the presenters of this session. Thanasis, Adnan, and Rasto will join online. But we are adding also the products. So Lars is joining again, and Henning is joining for, and Pablo is also going to join because the life cycle assessment is a key part. Please take a seat. First come, first serve. And then we have the additional chairs you don't need to play piano, but you can use some of the chairs that are here around. That should work. And we have a second mic, I think, somewhere that we can use for the panelists if it's already there. This one you can use here. And I really like that last slide. Good air makes a great journey. And it's for the person who is commuting or who is in there, as well as for the persons where you are driving by, that it's also good air for them. And that's also, I like that you had a dream. This could be something where we can use it for. That brings us to the panel discussion. And there was the question before, if we dream, how we can scale up things, how we can go. You mentioned already something for the metro, some use cases. Oh, there is a change. I see now. We have a new person here in the panel. That's not on the agenda, but it's great. And a person that was already mentioned before, because the filters that we use to collect the dust in the metro stations are the color of the T-shirt. So Thomas, welcome here from ZF on this one. And yeah, you have attended this meeting. Thomas, what are your dreams and your reflections on the day?
Is this working?
It's working.
Hello. Yeah, as already mentioned a couple times, there are great opportunities. So that's the major thing. There's still some challenges, some open questions to be solved, and especially the question how to get to the closer to the public and reach out for. I'll take this. All right. That's, in my opinion, a big question. On the other side, we already see some increasing interest, especially coming from cities, which is kind of a new approach because usually ZF is a supplier for big OEMs, and so the requests are coming from there. And there is much more pressure required from the final customers to get something into cities, into vehicles at the end, or in metro stations as well. Yeah, and also there are some new, or not always new, but some more initiatives coming up or working, like the City Climate Council, for example, and to really go for this globally, not just in specific areas, and that is making some or creating some hope on my side. And the vision is really to investigate a little bit more some of these solutions which are more or less 100 years old, for example, on brakes. They have worked for all this time, and now it's time to change. Obviously, and so there's a technical and a political opportunity, and let's see.
Okay, thank you. With that, I would look at Thanasis. You have listened a full day to this topic and also to AeroSolfd Solutions, and we have seen the Vera project. Which of the AeroSolfd you would like to add to Vera to make it something of a complete solution for cities?
Well, indeed, today I have seen in detail all the achievements of the AeroSolfd project, which are fantastic. I think the two projects are developing complementary technologies and solutions. I think these can be combined, particularly if we talk about brakes, then I can see further possibilities, and even more for the metro. You presented a very nice system for air purification. The Vera project is investigating some solutions to reduce production of particles, so these can be combined for even better air quality in confined environments, which I think is a major challenge. And I think in order to move forward, further to the technical solutions, we need also some strong frameworks and schemes from the regulatory side and from incentives for individuals in order to proceed to retrofits. The AeroSolfd project is investigating this. Vera project is also considering regulatory and incentive schemes. And finally, I think it is very relevant, as both projects are doing, to have the final cost-benefit analysis in order to see what we gain with what cost, and have a holistic evaluation of these solutions.
Thank you. Yesterday, we had an event of the IDEA cluster working on indoor air quality, and there was also projects working on metro stations. And the challenge was there how to communicate. Because you said good air makes a great journey, but on the other hand, if you talk that there is an air quality problem, people might not like to hear about it and talk about it. So now we are in the situation where we have some solutions and some results. So it's not only telling there is a problem, there's also a solution that you can pick, or more solutions that you can do. Pablo, looking at you with that life cycle assessment, with the citizen science we had in that project, are there different ways of communicating the tailpipe, brake, metro, and what does it help that there is now a solution?
Yeah, I think it is important to know that all the data that we get and all the numbers that we get, we you know, within a certain group of experts, we can see what that means. But then when you try to communicate it to policymakers or citizens, then the approach has to be different. And indeed, the impact of the three retrofit solutions and the extent of their application, once that they are deployed throughout the cities, are going to be different. So indeed, we need to know the story that we want to tell. The data is there to support it, but the challenge is now how we take the approach for citizens and policymakers to make it easily digestible and to create an actual impact. Yeah.
And what could the policymakers do? What would be the way to do? And then I might also look at Rasto online. You mentioned it needs some incentives and regulations. If you look at the brake dust, if you look at the GDPF filter here, what could be some policy, some tools cities might have to get these fast track started?
So I think one of the issues across different cities is that they do not yet see air pollution linked to non-exhaust emissions and petrol cars as a need to improve. So I feel some cities still fail to see the need, and projects like Vera or AeroSolfd help create and find that need. So they're actually, like you said, they show that there is a problem, and they also bring together the solution. So that in itself is already a path towards making policymakers locate that need that is not there yet.
I would have
in their eyes.
Thank you. I would have a specific question to Rasto, who's online. You showed that slide that if we combine approaches, if we not only go for electrification and wait for that time, but if we do something now with a retrofit combined, that can help reduce the PM emissions faster. What is the response if you talk about that to policymakers, regulators?
Well, I guess, yeah, thank you for that question, Martin. You know, there's a diversity of approaches that, and they get different responses, right? So when you look at new vehicles and bringing in new technology on new vehicles, that's, you know, that's fairly open and so forth. I think retrofits have the challenge of, you know, you're dealing with individual consumers and private vehicles. So you really need to incentivize the private individual to want to modify their vehicle, and that really requires that the vehicle's out of warranty, because you don't want to void the warranty by making changes. And also the technologies that AeroSolfd and Vera are looking at, the communication there is going to be different, right? Anytime you're approaching a fleet of vehicles or public vehicles like metros or public trucks or passenger car fleets, then talking to the city one-on-one and sharing the results of this project is, I think, an effective way. If you're trying to communicate to individual consumers, you can't possibly approach them one-on-one, so you have to go to social media and things that we now have that we didn't have during the diesel retrofit days. So I think thinking creatively about some of those ways to address consumers, right, end users, that only have one vehicle and you're asking them to modify it.
Thank you. Lars, you want to comment on that?
No, I was acknowledging.
Lars is acknowledging all these ways of and the social and that's Adnan, that I would hand over to you that question. It's a multi-level topic, and also the approaches are different with social media where you can reach people, and we have also seen that in the responses to our AeroSolvd that some are asking for solutions, some early adapters are there, but they are spread around, so it's not a single city. What are the experiences, or what can be contributed by EAT Urban Mobility, or what other thoughts you have for scaling up and bringing that to reducing emissions?
Yeah, well, I think like we have to take several approaches. There's not one thing that we have to do. We have to raise awareness. We have to work with policymakers, bring in the data that they need to bring about the interventions or incentives that are necessary, giving them all the tools, the cost-benefit analysis, the impacts, etc. We need to work with early adopters. It's good to see, for example, Metro de Lisboa or other early adopters in the fields, and they facilitate for us studying the solutions and gaining insights. And these are all levels where we help facilitate, bringing partners together. We help provide, as I said, funding for pilots, for demonstrations, but also we help communicate this information once we have solid data, and to provide to the policymakers through studies, etc.
Lars is nodding, but not adding at the moment. So we had that discussion in the beginning that yes, policymakers might be aware of. We can talk to them in different ways, but there's the PN, the PM, the particle number, particle mass topic as well. What would you, if you could dream, what would you say that would be great to have to implement this solution? And if that's not coming, my dream B and C would be?
It's always good to dream, Martin. I think the last three things that I will contribute to this discussion today is following up on your question, and that is three things. First thing is that I strongly believe that we have provided a solution in Work Package 1. The problem is that it's a solution for a problem that is not entirely recognized. So we are starting to fix a problem that's not there. And that is the awareness that the focus must be for gasoline emissions, particle number, and not particle mass. And it's difficult to persuade politicians to do initiatives against something that they don't know is a real problem. So that's where we start. Second thing is that I mentioned in my presentation this test of 1,000 vehicles where very few vehicles were actually responsible for a very large proportion of emissions. That is what we define as the dirty tail. The dirty tail is the low-hanging fruit in actually providing better air quality. Because if we can tackle these few vehicles instead of suggesting a huge retrofit programs for politicians who may be restricted by money and regulation and social consideration and industry standards and lack of regulation, if we can provide a suggestion of a very pragmatic approach where we say 10 vehicles out of 100 is the problem, let's detect them. But in order to find these 10 vehicles, we need to have proper and adequate equipment, procedures, and regulation to find these vehicles. And that you do by having proper periodic inspection. Today, we are measuring vehicles with opacity meters, which has absolutely no relevance to the emissions of a modern combustion engine. Even without any kind of after treatment, these vehicles will pass the test. So again, we are measuring micrometers with a tape measure. So first thing is regulation to make sure that we properly measure the vehicles in use. When we have that in place, we can actually find the 10 vehicles out of 100. And then, as Rasto said, maybe some of these 10 vehicles are so bad that they are beyond repair, and to do retrofit on a very bad vehicle makes no sense. So out with these vehicles, and then we retrofit the rest. Even that small fraction of the 100 vehicles to be retrofitted will make a tremendous contribution to particle number emissions. And that will be the low-hanging fruit, and that will be easier to digest in some sort of regulation, locally, regionally, or EU level. Thank you.
Thank you for bringing up that point of looking into the periodic inspection and checking. The PN topic, Thanasis, I'm looking at you're in a similar project. Is there that discussion going on in Vera as well about PN number versus mass and what is missing in the communication, or how do you address the need of the GBPF?
I think this is something that it is. Now? Okay. I think this is something that it is considered from the very beginning in both projects as we are discussing about particulate emissions from gasoline. We are also investigating natural gas, which actually have even smaller particles to the nanoscale. So indeed, it is a well-recognized point that needs to be addressed. I fully agree with what Lars has contributed to the discussion, the last 2 points that you just mentioned. So yes, we are investigating this. So we are investigating technologies of particulate filters that can address exactly this issue. I can say that in terms of mass, we barely measure something, but in terms of numbers, we have considerable levels. So indeed, this is very well recognized that I think indeed it is something that needs to be properly communicated to the decision makers in order to drive regulation and rules to this direction. And I fully agree with this last point that you mentioned, that a very small portion of vehicles are responsible for a very big part of the pollution. So practically it would be easy to address this issue as the low-hanging fruit, exactly. So I fully agree with what you mentioned before.
Thank you, Thanasis. Looking now, there was also a question how we can scale that up in Germany, in Spain, in the partner cities, Portugal, in Europe, how we can do that worldwide. Rasto, MECA has a global view on this topic, and it's involved in India, China on the topic. Is there already, and Mexico as well, so is there a similar discussion going on these PN, particle number, particle mass, and is there something also looking into retrofitting vehicles?
Well, I guess that's a couple questions, and thank you for that. So yeah, I think globally, 2/3 of the vehicle producing world already has new vehicles coming out with particulate filters. So they've already recognized the issue of particle number versus particle mass, and new vehicles are getting these filters on them. So I think they recognize the value, and convincing those areas that in-use vehicles have a contribution as well, I think is going to be easier. Unfortunately, in the US, we don't have GPFs yet, so we're still talking particle mass. But even with particle mass, I just want to, point out the differences in gasoline fuel injection technology between port injected and direct injected, and that direct injected engines actually emit higher levels of particle mass than a diesel vehicle with a filter on it. So I think addressing those vehicles is important, whether you're talking about number or mass. And back to the retrofit question, I think, diesel retrofits, I think, are being done in other regions for sure. Mexico City has done a large program. India is looking at them. I think they're doing it more on a city by city basis. China has had a extensive diesel retrofit program. So I think addressing diesel retrofits is being done globally, but what was really impressive to me is that this project took on the task of retrofitting gasoline vehicles with particulate filters, and I guess what Vera has done is really the only two examples I know of that in the world.
Lars, you want to comment on that? Thank you, Rastu. You get the mic.
Thanks, Rastu, for. I'm not sure this one is working. I think it should be up. It is up. It's not working. Thanks for bringing up that difference between the direct injected and the port fuel injected engines, because I actually forgot to mention that entirely. When we designed our testing vehicle or our fleet and the selection of test vehicles, half of the vehicles, which means in this case 2, and the other two were port fuel injected and the other 2 was direct injected, for exactly that reason, to make sure that we had covered that huge difference there is in particle number and particle mass emissions between the 2 injection types. So that was covered in the testing setup with Work Package 1.
You want to say? Hand it over. We can have a discussion in the panel. Feel free.
Yeah, I want to add something, because this was going pretty much in detail on combustion engines. I would say, yes, there is still a topic, but we also have a progress for the last 20 years. I mean, if you look back, there have been engines using 20, 40 liters per 100 kilometers. Now we're totally on a different page. It's not enough, yes, and also the attention has been drawn much more to emissions, really, which wasn't 20 years ago not so much the case. But I must also say what's also important is not only going into details on each topic. It's important to create solutions, but also to look for comprehensive solutions. And sometimes we also create some contradictory topics because it's new. Just one example is going for electric cars creates more brake.
Perhaps some of this is now working. Can you try that one?
This is the cable.
So it sometimes creates more brake activations. I hate to say that.
Yeah.
I shouldn't say anything. That's good. It's empty, probably.
I need a new battery, perhaps.
Let me give you yours for a second.
Okay, but you can change the seats.
Yeah, we roll over here. Okay, just to finish this. So if we go for electric cars today, or vehicles in general, the brake forces or the deceleration forces are reduced as well. So you might create more friction braking. And that's one topic, just as an example, where we have to deal with new setups, with new situations, and also to consider what overall are we doing there. We want to have transportation, we need this, and to find a new balance of all these topics which have been in the past not really recognized maybe is important, I think.
Yeah, and that I think the new non-exhaust emission study that EIT Urban Mobility presented, it's going that way of looking at a holistic approach, of looking into different cities, what has been the effect of low emission zones, how long does it need to really have that change, what Rastu also was mentioning, that it takes time until you renew the fleet, and the effects of shifting mobility from one mode to another, and looking at the cost as well in that way. So looking at that study, I remember, I might be wrong, that there was an effect about 20% of some of these measures to help to improve the air quality. And we are now adding here some more options with the brake dust, with a tailpipe. They have somehow in the filter, but I think it was non-exhaust, so the gasoline have not been in. Do you think that these solutions and what we have presented today, the values, are in a range that are of interest for the cities, or are they too low, too high, the effects that we have seen here?
I think it really has to be studied in a case per case studies. Like even the mix of different, like the participation of road transport, for instance, in the mix of PM emissions in different cities in different regions in Europe changes a lot. So I cannot just say out of the top of my head if it's relevant or not, but I think it's something that has to be obviously studied, that has to be taken into consideration, and the results of the work that you've been done needs to be shared with the wider public about it. And then obviously in each case the cities will see if a more general approach, and we've seen, like at least in our study, in the case of specifically in the case of London, there are some solutions that give much more benefit to cost approach, and sometimes they're more generic. For example, the electrification or the mode shift are big participant there.
Thank you for that question, and I was hoping for that answer, because that shows how complex the situation is and that you need an individual or city-based regional assessment. And that brings me back to Pablo. You showed some preliminary results. You should have marked all slides with preliminary, because the entire work is, because there was something that came up that the models that are used per se are one-sided, or only look into some parts of the problem, but not into the full. Why is it noted so late? That was one of the questions for me, because it's so much standard, and how can we change that? And is there some other work also ongoing where we can contribute now as AeroSolvd to give them a change in that way of looking at the life cycle assessment, to make that a tool for assessing the effect?
Yes, so for the life cycle assessment, there are many models that people use around the world. There is a TRACI, there is a CML, environmental footprint, recipe. Many of them use different units to measure the environmental impact. One of the most widely used is the recipe model. So for example, when you talk about climate change in terms of kilograms of CO2, that is also what the recipe model uses. So that's the most widely used, I would say, and also in research and academia. However, there is a push to create a bit of a standardization of the impacts, so that it could be a bit more relatable to the general audience. And then some of these newer models that are being developed, they take into account impact, however minimal it may be. They take into account a compound that will have an impact in the next 40 years or a 100-year horizon that the recipe does not take into account yet. So when we were having these discussions within Work Package 4, we saw indeed that there is a difference in the way both models calculate the impact. So the emissions remain the same, But how does that translate into an actual impact? Yeah, there are the most widely used model, Recipe. I would say it doesn't really fall short in some cases, but it argues that the impact is allocated into a different indicator. So in the case of a Recipe, what we saw was that it allocates human toxicity altogether, and some other models does have the distinction between non-cancer toxicity and cancer toxicity for some specific compounds, such as the polycyclic aromatic hydrocarbons.
Kjell Alsop Jensen from the National Research Center for the Working Environment. I was actually thinking about the previous discussion where we consider that different solutions might be most beneficial for different cities. But I wonder if that's a feasible, practical approach, because if in one city you need to have a breakware filter and in another you need to have a tailpipe filter, what would that mean on a global scale, European scale at least? I cannot go to Paris because I don't have a tailpipe filter on my car. But I could not go to Copenhagen, for example, if I don't have a breakware filter on my car. Do we not need a uniform approach for the implementation to make it work?
Well, I think you're absolutely right in your question, and I think there are two parts to it. There are obviously general approaches and general solutions, and we've decided that, at least from our side, we believe, and the results of the study has shown us that the generic approaches are definitely modal shift, because it provides not just benefit. For example, in the context of the cities, modal shift in electrification and decarbonization in general are the general approaches, are the future direction, the way we see it. It provides a solution not just for the non-exhaust emissions or for the air quality, but it provides wider benefits. So these are the prescriptions, I guess, that could apply on a general basis, but there are situations where different fleets, for example, different geographical conditions of different cities might require different approaches, different solutions, and I'm here not speaking about the individual cars or the individual transport modes, but specifically in the cases of fleets for transport, or in the case, for example, of metro solution for the dust in the metro. What applies in Lisbon might not apply in the case of London with all its complex and old systems, etc. So yeah, but thank you very much for the question. I think it's very relevant.
So it might be local driven, but hopefully getting on the European level to allow the way of going for the brake and for the tailpipe. Going to the retrofit solution, Rasto, you mentioned in your presentation that the average car is 12.3 years old. And there's a question from the audience, from the online, who will invest in a solution of a retrofit? And Lars said it's an affordable solution to just have the car running a few more years. You have that experience because you did already retrofit. What can you say about the people who would do that, and why would they invest in?
Yeah, no, I think those are all questions that consumers will have to ask themselves: is at which point do I get rid of the car versus, retrofitting it? And I think each individual is going to have a different answer to that. So that's, I don't think it's a universal solution for every vehicle, but I think those vehicles perhaps that are still operating well, some people are very good at maintaining their vehicles, and so retrofitting for them makes sense. And if that allows them to get into a low emission zone, then it also can pay for itself. So I think that's probably the way that we have to approach this, is diverse solutions for individuals depending on vehicles.
I see Lars nodding that there is a chance that people will pay for. That's great. Now let's move on to also the feedback of citizens, the feedback that we got on the project. We had some side events before in Copenhagen. We heard about that already in Amsterdam and in Lisbon. Pablo, you have been at the Amsterdam event, quite active. Can you share some feedback about that event?
Yeah, so in that event, we had participants from the government and also from private institutions and from, let's say, citizen engagement. So we had a bit of everything. And of course, the one of the main differences was the scale of focus of each one of these participants. So we had a party that's called the Clean Air Agreement, and they focus mainly on the impact of air pollution on citizens, and it's run by citizens. And it started as a voluntary work, and they tried to push the government to push forward policies. And within that project, well, within that organization now, many municipalities have joined it and are working together with the citizens, and their focus is quite local. So they are people working for the people, and then they perceive they perceive air pollution as something quite direct. And at the same time, we had a person there from the Royal Institute of Meteorology, and they're also focusing on air quality and nitrogen dioxide. But of course, they're looking at it from a larger scale, so countrywide. And from all the participants, what we could see is that they were not entirely connected between each other. So they actually, after that satellite event, they suggested it would be a good idea for the Netherlands to have a common platform where policymakers and other governmental and private institutions could actually see what everybody was working on at the same time, and what the potential solutions and achievements have been, because today there is no such platform.
It sounds promising. And before we go to the metro, as a different part, we have Lauretta, CEO of Word, and in the tailpipe work package engaged. You would like to do a comment or raise a question?
Yes, please. First of all, it's an amazing event, so I would like to congratulate everyone for such a fantastic presentation, and all the team. It's been really nice to work with all. I just wanted to add something very, very small, because I don't want to. I'm very sorry that I could not participate personally there, but as Lars already mentioned, just going back to the Retrofit program, extended also to the port fuel injection vehicles. And I want to stress also this point, because it was said that generally, particle mass, of course, is not really a big deal for PFI, but actually it can be, because actually WERT has been, studying quite a lot of PFI, different vehicles. And actually we found out that sometimes PFI can be as polluting as GDI. So, and this is why we decided also to extend the investigation to PFI, and in the 4 different engine families, we included also these 2 PFI vehicles. And in addition, also the GRC, so the EU is currently also investigating PFI for potential PN emissions legislation together with the GDI, because we know that the GDI has been already legislated far back in 2017, and also with our NPTI investigation of the gasoline vehicles, where we tested, unfortunately, not a lot of GPF-equipped vehicles, so Euro 6D, but definitely, PN level are much, much lower. And I want to stress the fact that by applying the retrofit, that is a very cost-efficient solution and a really fast track to commercialization, we definitely can immediately promote and improve air quality. So this is the only comment I wanted to make.
Thank you, Lauretta.
Thank you again.
Thank you for that one. And improving air quality, talking about air quality, we heard that's a challenge for metro operators. Metro Lisbon is doing that. You had also an event in Lisbon. Tommy, can you share something about that event, the feedback we got, and what people are expecting?
The satellite event, and it's working. So it was great. So because we have different participants explaining especially from the regional and local, but also from the associations that manage different parts of stakeholders of these areas. And one of the things that I think it was spoken there, it's like previous you have like this clean water. So you have the water for nowadays. You have you go to a bathroom or public bathroom. You have the clean water. So this is automatic, like it's expected. So the air in the future must be like this. So it's expected that the air quality it's better. And the levels of air quality increase for a better health and a better journey of our, especially in the public transportation in the cities. Yes. It's
So before we finish and before I give up with these mics, we just one question on the metro. What would be a way forward for the metro systems? How can you get that it's Metro Lisbon now? How can you get that to other metro operators? What would be needed? What could be some next steps?
So this team of air quality, it's a team that is increasing present in the discussions in the different forums. So we, Metro Lisbon, participate in the benchmark forum that is managed also by together with colleagues, with Guilherme. So where we share good practice, and the question of air quality is increasing, be present. Also, there's the WTP. This is the Organization for Public Transportation. This also this is a worldwide organization. The question of air quality it's increasing present, and I think this must be followed by policies, but also by the public transportation. Sometimes you have to be proactive. So. Testing, because I think it was previous some question about the specific. So this is there must be general policies, but also specific policies that are related with the city and the requirements and the issues that the type of transportation and the type of environment of that city or that region defines. Yes.
Thank you. And before closing, I would like to ask everybody of the panel to say one sentence about what is your take-home message, what you take home, and what is your dream for the next step. And I will start with Rasto, who is the farthest away from us. And the first goes to you. What is your take-home message, and what would be your dream for the next step?
So I think the take home is really that the demonstrations have been very impressive, and demonstrating technology is something that Mika has done throughout its existence, and it's an important first step to start the conversation. And then as far as next steps, I think taking this information to our respective stakeholders. For example, in the US, I think one of the things I'd be very interested in sharing this with California, because they really take the leading role in air quality. They took a leading role in diesel retrofits, and so I think sharing this kind of information with some key stakeholders that we each have, I think would help to get the word out and perhaps get some broader interest.
Thank you. I continue with Adnan. You can pass this mic around and then give it to me.
Yeah, no, I think the take home. I think it's amazing to see all the work, the breadth and the depth of the work done within the AeroSolfd project, but in the field in general, in Vera as well. And I think that's the take. There's loads of information. There's an understanding of the problem. There's an understanding of possible solution. There's work done in the innovation, and now it's a matter of like how do we turn that into actionable work, right? Like how do we take action based on that? And I'm looking forward to the conversations that we have afterwards and to bring these things into our life.
One sentence is difficult for me. I will try. Dissemination, communication, awareness, building up showcases. Maybe Adnan is going to be my new best friend in trying to build some business and scale up things gradually. And let's just try and say, let's be the benefit of the doubt that particle number emission is dangerous to human health. And we had a lot of actions mitigating consequences of COVID. My claim is that we are killing as many people by air pollution every year as COVID did in 5. So let's move on.
I think I will agree with what has been mentioned already. Technologies are there. We need to find the ways for their widespread application by communicating the exact problems that these technologies are going to address.
Yeah, my takeaway basically is, again, I must say that subsidy projects in this content are pretty helpful because you get a lot of different views, and that helps also for following up on these or other topics. So I really appreciate the contribution and cooperation. My dream, I must really say, is still to not forget that we are claiming to live in a democracy. That means the society and the public is driving this. And that means we have to inform them in a way they understand what we're talking about. And to make it simple, I don't think if we come up with PM milligrams and parts, it's the way to tell people why they should care. So we have to find better ways, and then we will succeed here.
So we learned a lot with this project. So we have like a background of air quality in our system, but we learned a lot with this project on the monitoring, but also on filtration units. But we need to learn more, but also to implement these type of solutions. And some ideas that I share in the last slide are some things that we can do in the future. So let's do it.
I think for me, one, maybe in 2 sentences or 3, I feel that AeroSolfd project has actually achieved a solution that can be implemented today. And as Lars would say, has said in the past, we have managed to assess, or we're still doing it, so that we do not bring something to the people that does good on one hand and then does bad in the background. So I feel these solutions that are implementable and you know we can deploy have in the background the overall sustainability assessment, so that you can actually tell the policymakers and citizens that there are many other indicators that the filter is being good at.
So this brings us to the end of a European project that was initiated by that call, and we can see how great it is to collaborate in Europe. You are bringing different ways of people thinking, perspective, different disciplines together with the funding. That's creating itself a great benefit that we have with that. And we are now ready for the next step. And that will be, again, collaboration and talking with others. And that was good to know and to see. And with that, we are almost going to close the session here. We have, thank you for joining online. We will let you know if you follow on LinkedIn about the next steps. What we will do, we will take a group picture, and that will be of the people in the room plus the people who want to switch on the camera, or how does it work? So if you want to be on that picture and you are online, keep your camera on. If you are in the room, you are kindly invited to come here to the front. I think you can sit where you are at the moment. The others might pile up in the back, and then we can have a nice group picture. And with that, after that, then we will end that project here, this meeting, but we will continue and looking forward to the next steps. It was a great day. Thank you for being here. Martin Niemann, Mannen Hammel, coordinator of the AeroSolfd projects. Thank you.
Perfect. With the old glasses.
Keep the T6 sign over there.
Da muss nicht hinlegen. Vorne muss man das hinlegen.
You want to be
We all... Yeah, okay.
Goes by 8. Goes by 8. Does it?
We are almost ready. We are missing the Steinbeis 2 persons. We take one picture with Rasto, and then we take one picture without online. You can put them on? No, you can't put them on. Yeah, that sorry, we can't. We just have Rasto here as one picture with him, and then we will have also a picture, just the persons on site here. And I need to show the mic all that time for the picture.
Come here, Carlos, come here.
green.
Yeah. You're green now.
And you want to bring it out there? Thank you, Rasto, for joining, and have a good day. Thank you all. And this is now the start here on site for the networking. That's one important thing. Oh, sorry, I forgot that one. We have a new video. So please stay and look at our new final video. It's really great. Let's look at, and Thanasis, watch very careful. There is Vera in.
Meet Luke, a smart 12-year-old boy. He loves playing video games and dreams of becoming an astronaut. He likes exploring his big city, but there is an invisible challenge affecting his health every day: poor air quality from traffic-related emissions. Besides the more visible emissions, tiny particles are also emitted. They can be categorized based on their size. Two of the most common categories are fine and ultrafine particles. They are so small that Luke cannot see them, but they can be harmful to our environment and health. Combustion engine vehicles emit tiny particles through their exhaust systems. As vehicles brake, particles are also released into the air and circulate around. While waiting for the train, Luke breathes in particles from sources like train brakes, outside air from the city, or maintenance work. The air is trapped in these spaces, so the air quality worsens if it's not replaced with cleaner air. Luke, like many of us, is unaware of the impact of the particles he breathes in. Generally, the smaller the particle, the deeper and more concentrated it can penetrate the lungs and travel to other parts of the body. Air pollution affects everyone. Some groups, like children and teenagers, are particularly vulnerable because their bodies are still developing. Traffic-related air pollution can damage buildings, contaminate soil and water bodies, and contribute to global warming. The latest scientific evidence shows that particulate matter has a significant impact on our health. Chronic exposure can affect every organ in the body, worsening existing health conditions. The effects on human health include reduced learning ability, which affects children like Luke and Vera, as well as developmental issues and asthma attacks in both children and adults, among others. Studies show that exposure to fine particles leads to increased rates of hospitalization for respiratory and cardiovascular diseases. Every year, several million people die prematurely from traffic-related emissions alone. What actions can be taken to address this issue and its wider impacts? While there's no single solution, retrofitting existing vehicles and improving semi-enclosed environments with AeroSolfd filtration devices can significantly reduce particle emissions, creating healthier cities for everyone. AeroSolfd has developed 3 low-cost, adaptable, and environmentally friendly retrofit solutions, including brake dust and tailpipe filters, as well as air filtration systems. Once implemented, AeroSolfd Solutions will reduce urban pollution and contribute to healthier cities. The new AeroSolfd filtration device will make the air cleaner for Luke when he is waiting at the metro station. The bus will be equipped with a brake dust particle filter, helping to reduce fine particles in the air. Brake dust filters are also important for e-mobility, as electric vehicles produce minimal exhaust emissions but still generate substantial brake dust. Older petrol cars are now equipped with a tailpipe particle filter, which effectively traps ultrafine particles. AeroSolfd Solutions support the transition to cleaner mobility and a healthier environment, improving air quality for Luke and his community. When will your city benefit from AeroSolfd? Learn more about our research and how retrofitting can contribute to healthier, more sustainable cities. AeroSolfd, fast track to cleaner urban air.